এই হলে বলো, আমরা জয়েন করবো। হ্যাঁ, ভিডিও অন করবো।
It's approximately 10 o'clock, around 10 o'clock. Should we start? Okay, thank you, Maharaj.
Sir, your video, on the video of the lab and yours, yeah.
And Arnab, a lab video and your video should be on all the time.
Okay, Maharaj. Sure. Thank you. Should I start, Maharaj?
Yes, we are already late.
Okay. So, good morning, all of you. I would like to, myself is Dr. Arnab, Assistant Professor, Department of Sports Science and Yoga at Ramakrishna Mission Vivekananda Educational and Research Institute, also known as Ramakrishna Mission Vivekananda University at Gwalior, Howrah. So today I would like to welcome our revered Pro-Chancellor, our Chancellor, Vice Chancellor Maharaj, Swami Sarvottomanandaji Maharaj, our Head of the Department, Mrinmoy Maharaj, and all the delegates present or attending virtually and offline here, and all the dignitaries and faculty members, organizing secretary of or organizing committee member of APPI and APPICON, all the faculty members of Department of Sports Science and Yoga, all PhD scholars and dear students. So welcome to the 67th Annual National Conference of APPI, that is Association of Physiologists and Pharmacologists of India. This year, the entire conference is going to be held at, organized by Department of Physiology and Pharmacology, ESI Medical College and Hospital, Faridabad. And the today's pre-conference workshop, which we are conducting, I am happy to share that it's out of 8 workshops organized by APPICON this year. 5 workshops are going to be held at AIIMS Delhi, 1 workshop as DIPAS DRDO, and another 1 workshop on sports and exercise science that is going to be held at Department of Sports Science and Yoga at Ramakrishna Mission Vivekananda Educational and Research Institute, Gwalior. So at first, I would like to, I request you, our Vice Chancellor Maharaj, Swami Sarvottomanandaji Maharaj, to address the gathering and say a few words to the audience.
Thank you, Arnab. Dear participants, dear professors, dear dignitaries, I wish to say a few words at the beginning of this workshop. My field is computer science, so I don't know much about sports and medical sports science and biomedical science. So I will be very brief. I will only tell you about what our idea of sports science and related subjects are. First of all, I would welcome all the participants, and it is our great honor to hold this pre-conference workshop, and later on we will have a seminar conference also, which will be held in our institute. Some of the participants will be offline, and most of the participants will be online. Everyone, all of you know that this is a very prestigious conference and workshop, and only a few workshops and conferences are held all over the country. Mainly, I think only in AIIMS, and total number is also less than 10. This is the first point. And second point is the need for sports and exercise. This is again according to me. See, we Indians generally, they don't give too much importance to our physical development. And also I think because we are not much interested in physical and development, though we say that we opt for mental development and spiritual development, but I don't know how it will help if we ignore, because our existence is of all three. In Vedanta, we are actually, our existence consists of physical existence, then mental existence, and spiritual existence. And there should be harmony between our body, mind, and spirit. So, really speaking, if we ignore one part of it and try to support and try to develop only another part, I don't think it will be helpful. The Western civilizations, they go other way. They only look after physical development. They don't care about the mental development. In fact, they don't even know that whether mind and spirit and the soul exist or not. That is why they only worry about the physical development. But you may wonder why we talk about yogas. So yoga is actually mental development along with physical development. So in India, we have both mental development and spiritual and physical development. So physical development controlled and directed by mental development. But anyway, so if we forget about the physical development, we think that we are catering to mental development, but that is not happening. Mainly, that is why we not only fail in our physical department, that is, that we are not in top of the world in sports, but also you will see that we even fail in the professed mental department, because we are not even the pioneers and top in the world of ideas and research. So I think it is high time that we should care about each and every aspect of. See, I have become old, so I have come to this realization a little late, because when I was young, I also did not worry too much about my physical well-being. But now I understand that physical well-being is an important part, and that should be taught to our children and our boys, young people, right from the beginning. It's if we are taught when they are already 30 years, 40 years old, then it is very late. So we have to have all three all-round development of physical development, mental development, and spiritual development inculcated right from the beginning. Though difficult to bring spiritual development in our modern curriculum, but mental development along with physical development should be there. With this, I will finish my speech. Thank you very much.
Thank you, Maharaj, for this beautiful speech. We got some vision and what we should do and what is the current situation exactly highlighted, particularly in sports and sports science, but in Indian context. So yes, exactly, we are lacking somewhere. So that's why if we see the Olympic medal count, or although in this Olympic, last Olympic, Tokyo Olympic, we did really well compared to the previous one, but yes, long way to go. And hope in that aspect, sports science can actually help and benefit, can play an important role to inculcate to improve the sporting culture in India, and also to achieve a lot, because sports is another domain through which nations recognition also comes to the surface basically, and everybody's visibility. So thank you, Maharaj, for your words. And I think next we can go to the introduction and orientation to various labs of sports science and tools and modern techniques. We can discuss on that. So regarding that, I would like to share a PPT, and we'll see. Just give a few seconds to us to share the screen. So, as I said, so I am Dr. Arnab Das, and I am also the organizing secretary of this workshop. And today we have with us all the faculty. So today we are going to demonstrate several sports science domain and experiments, starting from EEG, metabolic gas analysis, anaerobic test, and then for after that the biomechanics movement analysis we'll go through. So basically, at first I would like to thank Association of Physiologists and Pharmacologists of India and the members, executive members and organizing secretary of APPICON 2021 and 2022 for giving us the scope to organize this workshop from very far from the organizing venue and as a satellite center. We are happy that we got this opportunity, and thank you everyone for this scope. So at first, I'd like to put some light on our university and our department as well. So our university was started in 2005, and the vision was it's a center of learning, blending with twin excellence of ancient Indian wisdom and the modern scientific knowledge and technological skill from the western part. So our university is a deemed to be university, and I'm happy to share that we got the NAC A++ accreditation from the government of India. So our university is a multi-campus university in which we have 4 campuses. The main campus is at Belur, Howrah. Another one is Coimbatore, where we have mainly run the physical education courses, and there we have a very good infrastructure of field exposure and track and fields, indoor stadiums, and all those things we have there. And basically, the main population there, we target the general adapted physical education or adapted sports. Another one campus we have at Jharkhand, Ranchi, and another one is at Narendrapur, Kolkata, West Bengal. So this department, the Department of Sports Science and Yoga, is housed in Attovikas building, Attovikas Bhavan, which is a G+4 building, and started in the year 2012 as a full-fledged academic department to promote scientific study and research related to sports, including adapted sports and yoga. Basically, we run various master's, PhD, and MPhil programs in sports science and yoga. So now coming to the what is sports and exercise science, which is the main goal of today's workshop. So if we see the right side picture, so in sports science, there are various domains, particularly namely the physiology part, biomechanics, psychology, anthropometry, which basically deals with the body composition, training methods, which kind of training needs to be given, kinesiology, biochemistry, if any injury happens, then sports medicine and rehabilitation, and sports genetics, some emerging domains as well. So sports science in India, I'll say it's still at the budding stage, or it's an emerging field compared to other disciplines or academic disciplines. So in the department work or activities, if I like to say, so our main goal is basically, or the role of a sports science basically works as in the academic area. Another wing is the research area, and third one is the clientele support, to support various private academies or government academies so that the performance can improve, or working with the coaches on field. So sports science in India basically has made a significant contribution to athletes' achievement in reaching their peak performance. That is the athlete's goal basically, how they can improve their performance and do their best at the national level or at the international competitions as well, like Asian Games, Commonwealth Games, or in Olympics. So it's a vital stage of an athlete's career, which starts from the talent identification, then talent development and nurturing towards peak performance. So sports scientists employ a variety of new tools to track players on regular basis on field as well as on lab setup to improve their training, diet, mental strength, as Manohar said, and among there are several other things as well. Okay. So I think everybody knows this person and sports person, Neeraj Chopra, and in Olympics he brought the laurel, the gold, precious gold to our nation, to our country in the last Olympic, Tokyo 2021 Olympics. So how a major championship or how they reach to a major championship. So basically sports science work in the first level is the data gathering and assessment. The second phase is goal setting, discussing with the coach and sports scientist and various other administrators as well, or the association or federation. There are certain goals they used to set. And after the goal setting, there are several prioritize and targeting. So which game needs to be prioritized or which athlete that needs to be selected, and accordingly how to excel their performance. That is the plan development and implementation of that plan and execution. Then only we can do something good in a major competition or major championship. So if you see this flowchart, the scientific evaluation of athletes, the first phase is basically planning. So after discussing with coach, based on the coach's training regime, when the athlete or the subject is available for the evaluation, so then only according to the training plan, or there are different stages in training plans, starting from preparation phase, general preparation, then base preparation, pre-competition, then competition. If we consider a 2024 Paris Olympics, the competition has already started, the planning. So during this time, in the next, we have approximately 3 years time, less than 3 years maybe. So during this time, how many evaluations the subject should go or the athlete should go, different kinds of evaluation. What are the different scientific evaluation they used to go? That is the physical assessment, how their body fat or body composition, how it's improving, decreasing, how much it should be. The physiological assessment, biomechanical assessment, biochemical assessments, considering several enzymes and hormones, psychological assessments, the mental toughness, those things. And after doing this kind of scientific evaluation, the role of a sports scientist is to prepare a report, maybe considering a game wise, maybe a center wise. It can be an individual report, or if it's a team game, then a comparative report in that whole team where the athlete is actually relying. So out of 24 or 30 players in a football team or in a hockey team, where they actually stand and how much they need to improve above the team's average or considering the international counterpart. So those things is to be there, and if anything is lacking or anything is within the range or good, that is the role of a sports scientist to report basically. And based on that report, we used to send it to the center or coaches. And after the data analysis, so we can do the comparing of the data center wise, or we can prepare a rank list. Particularly the rank list is useful for identifying talents based on the fitness, based on the skills, considering several variables. We need to prepare the rank list. So now in the second slide, as I shown, there are different departments in sports science. So one of such is the first one is the Kinanthropometry, or which basically concerned with the measurement of human body size, shape, proportion, composition, and maturation. You can see all the offline participants, the left side, there is a stadiometer we have, that IOI. It's a body composition analyzer, basically deals with the work in the principle of bioelectrical impedance and the wind scale as well. So at first we need to know the physique of any athlete or any sports person. That is what is the muscle mass, how much is the bone mass, body fat percentage, which can be regulated, manipulated, or altered through proper training. Because in some sports, higher body fat percentage can adversely affect athletic performance. Another one is the hydration level, particularly especially important for endurance athletes. For example, marathoners, cross-country cyclists, skiers, cross-country skiers, or long-distance swimmers as well. What is the hydration level? Somatotype means which kind of body shape they have. So all this information basically leads to which kind of training they should undergo, or they are fitting in that particular game or sports or not. If I come to the exercise physiology lab assessments, so there are in sports, in exercise physiology, 4 basic pillars are there. One is that in each game, there should be certain strength, power, endurance, and along with that, agility and flexibility part. So maybe for marathoners, the endurance components they require more, power component requirement will be less, although it's required. If I consider Usain Bolt, a 100-meter sprinter, for him, he needs maximum explosive power and speed. But the endurance component, he needs less. So basically, we evaluate the exercise physiologist support we provide is the basic assessments are strength assessment, including back strength, leg strength, grip strength. It's all are isometric strength. Flexibility assessment, how the body is flexible, particularly in gymnastics. Or if we see our modern days competitive badminton or other sports as well, where high flexibility and agility is required. Next one is the endurance evaluation, which includes evaluation or assessment of maximal aerobic capacity, submaximal adaptation, and recovery response. To be very frank, we mainly focus till now on recovery. We put very less emphasis after the training, and the monitoring is not adequately done till now, although the trend is changing, particularly where the recovery is important. For example, if we consider a judo match or a taekwondo competition or a boxing, simple. So where an athlete generally gets, after a bout, there will be 1 or 1.5 minutes or 2 minutes break. So if someone's recovery response is fast and rapid, the next bout he can use or she can start with more energy and power and enthusiasm with the mental toughness, I feel. If the body is fully fatigued or almost fatigued and the recovery response is poor, obviously second bout or third bout. This also happens particularly in team sports as well, where an athlete needs to take 1 or 2 multiple sprints. For example, football or hockey. In wing position, they need to run very fast. After that, they used to get a very less time to recover. Again, they need to run fast. So those things need that area. In that area, several research is going on. Another important pillar is the anaerobic quality and power. The power, speed, endurance, and lactate threshold. Next, coming to the another important domain, which is also a part of today's workshop, and we'll start with this workshop only, that is the neurophysiology and cognition work. We'll see the EEG response, basically the acquisition of how to collect EEG graph or EEG recording when a subject is performing a cognitive task. So that we'll see what kind of brain waves are coming. So what are the techniques we have in the neurophysiology and cognition lab, a computerized psychophysiological test and analysis. These batteries we have, brain activity patterns we can evaluate through event-related potential or encephalography, electroencephalography. And polygraphing recording is also done for multiple biological signals, which actually influences the cognitive task. Next, another important, which is again and also a part in biomechanics, which will be in the post-lunch session, basically, and hands-on demonstration and hands-on training on acquisition and analysis of exercise-related body movement. For example, in the right side GIF, you can see our faculty on the Manohar Pahan sir is doing a squat with a lift, with a weight. So during that time, how the things will change or in different sports and games, you will explain during that particular workshop. So basically in sports biomechanics, it deals with power, force, and for that, and how the muscles are, which kind of muscles are getting involved during each activity, involvement of motor neuron, sarcolemma, these things. So we can detect it through electromyography. And another important aspect on field and in lab setup as well, that is the motion analysis. So if we know the correct joint angles and movement, or correcting or rectifying those movements or angles during training procedure, then athletes' performance, we can improve athletes' performance basically by correcting the angles and motion basically. Another important pillar is, which is highly associated with the training aspect, the strength and conditioning lab. So you can see there are a few pictures where the weight bars, different weight training stations, strength training stations are there. So it's basically to manipulation of load and volume intensity of the training plan, just to improve or put a lot of stress or adequate stress on an athlete's physiological system or body, or to alter or disturb the homeostasis of an athlete, so that the positive adaptation happens in athlete's body. For example, muscle hypertrophy or hyperplasia through a proper strength or resistance training. we can do after a certain time, maybe a 3 weeks, 4 weeks, what should be the duration, how much load, how many repetitions the athlete needs to be done, or the volume, how much weight the athlete should carry to lift. All those things basically done by a strength and conditioning expert. So this is another important domain. Another is the sports psychology. So you can see the subdiscipline of psychology, deals with mainly the people and their behavior in sports and exercise activity. Most probably you have seen, if it's a competitive atmosphere in the training schedule, some athletes are doing very good. But when it's coming to the sporting arena, when they are entering into a stadium, or if any major competitions are there, their performance is going down. Although they are doing best at when they are just simply practicing on the ground or in-house or competing with the known athletes. But when there is an international counterpart is coming, so in that area, the crowd, the athlete sometimes gets anxious or anxiety is working, and because of that, their performance is decreasing. So this basically it deals with the sports psychology. It works with the sports person, with the coaches, event officials, spectators as well. So the main objective or aim of sports psychology is to facilitate optimal performance to athlete in a given time period by training arousal regulation and providing cognitive training, basically. So there are basically several questionnaires are there, neurofeedback, biofeedback systems are there to train the athlete to improve the mental toughness. Another one important is the sports biochemistry and sports nutrition. So it deals with basically if we want to know the overall health and fitness status of a player or a team. For example, in Indian women athletes and also in male athletes as well. So anemia is very common and predominant. So to know if we suggest someone or the athlete is in endurance type of event where he needs a higher number of RBC for simple thing and the hemoglobin as well to transport higher amount of oxygen. If somebody is with anemia, and if we don't know, if the coach or the professional sports scientist tell repeated times that you need to improve your endurance, but there is something which is pulling the whole performance. So that basically can lead to injury and several other things as well. So it's a very important to know from the biochemical aspect what is the health and fitness status. In the biochemistry level as well, what kind of training adaptations and overtraining is happening, what is the hydration status, nutritional status as well. For example, vitamin D, calcium concentration is adequate or not. Anabolic activity, after a certain exercise or workout, anabolism may happen or catabolism can also happen. So, but to build up, if the goal of the training plan is to develop muscle mass or do some hypertrophy, hyperplasia thing, then obviously we need to incorporate those trainings which will basically boost the anabolic activity in our body. And the main one of such hormone which directly associated with anabolism is testosterone, and cortisol is a catabolic hormone. So what is the level of the testosterone and cortisol in the body after training, before training, after training, those kind of things we used to monitor. Then if overtraining is happening or not, so to detect that, there are several inflammatory markers as well. And what is the exhaustion level, the readiness of the athlete, which to measure their resting lactate, there is a peak lactate or aerobic lactate, anaerobic lactate, there are several lactate values and lactate threshold as well to improve aerobic or endurance. And another area in biochemistry, that is the main goal, is the anti-doping rule violation, and to protect an athlete and play fair is the another goal, where we need a extensive biochemistry department support and talent identification as well. So sports injury and rehabilitation is another important domain, where basically sports medicine doctors or the physiotherapists support the athletes if somebody got injured during training, during exercise, or during a major competition. So most probably you have seen several YouTube videos and Facebooks also. Sometimes we used to see in major competitions some injury happened. So basic first aid, what should be the basic first aid, kind of CPR, all those things. And if we can transport it to the hospital, that time what kind of precautions the subject or the professional needs to take, and after reaching the doctors. Because in case of general population, and practically and frankly speaking, the recovery phase, because the tendency of an athlete, if he or she gets injured, he will try to return to the field as early as possible compared to other. If it's a simple cold, cough or fever, or if it's a major muscle or bone injury as well. The athletes will always try to return to sports, game or on field in the field at earliest. Compared to other sedentary population, we can take rest for several days. But in case of athletes, there is that kind of tendency. So sports injury and rehabilitation is another important aspect, which basically works with the athletes directly if they got injured or they need to improve their performance or if any kind of functional loss or impairment happened. So apart from the sports science, now we'll see a different point, the several MSc programs, PhD programs, MBA programs, sports management. In the case of MSc programs, there are several institutes in MSc in sports science, MSc in exercise physiology, MSc in sports nutrition. So this figure basically gives an idea where and what we have the different sports science institutes, education in India. So you can see the QR code is given in the right side bottom. If you scan the QR code right now, so it will redirect you to the Google map and you can see all the university websites and their homepage in the Google map. You can try if you want, anyone. So those who are attending online also, you can scan this QR code. I think it will redirect you to the Google map and you can see the list of all the institutes. And anybody is trying? Yes. Anyone is trying? Should I move? Can I move? Okay. Okay, so this is the forecast now, what kind of job aspects in India by 2022, particularly in the area of sports science. And so where you can see different talent identity, sports science and technology, it's a prediction or it's an estimation. And it's the source is already given in the bottom. You can go through it. So sports science, technology, and sports management, there are different various job opportunities are there in coming days. Sports medicine, sports coaching, so those things, even a sports event management as well. And you can see the sports manufacturing aspect. So it's basically deals with that. Okay. So if we see the career prospects in sports science and sports and exercise science after doing any kind of program, and so that is in sports industry, there are several opportunities, and fitness industry. I'm showing this basically, this is a very budding stage, the entire sports science in India. The culture is changing. The candidate can have a higher education opportunities like PhD opportunities and teaching, occupational health and safety, like private companies or corporates. They used to have to improve the physical fitness profile or the work profile of their employees, and healthcare industries, particularly hospital and rehabilitation clinics as well. So this is today's workshop program details. There is a minor change in the program schedule. That is the exercise, the schedule which you got yesterday or today morning. There you can see the exercise physiology lab assessment of aerobic capacity. It was from after this presentation, after a tea break. But the Eeg experiment will there is a change in the serial number 4 and 5. Just 4 came up and 5 came down basically. So first, after this orientation, I think you got some idea about the various labs of sports science, various domains, tools, and modern techniques that obviously we'll see during the workshop. So if you have any question or any doubt, you can ask. Thank you, all of you. And once again, I'm welcoming all of you, all the delegates and everyone to the workshop. And once again, thank you to the organizing committee for giving us the support. So now those who are attending offline, for them we'll take a tea break of 10 minutes. After that, we'll directly start the Eeg experiment. That will be from 10:40. Right now it's 10:35 approximately, maybe 10:40 or 10:45. We'll start the we'll be in the neurocognitive lab, all the participants, and there we'll see how Eeg recording, we can acquisition of Eeg recording during a subject performing a cognitive task. Okay, and understanding the EEG wave pattern as well. Okay, see you soon, everyone. Thank you. Welcome back, everyone. Hope you can hear me. So now we'll go for the another next session, that is the neurocognitive laboratory and acquisition of EEG recording in a subject performing cognitive tasks and understanding the EEG wave pattern. And the resource person for this EEG workshop is Dr. Arkadeb Dutta, faculty of RKMVERI, Belur, and Department of Sports Science, and Mr. Sanjay Majhi.
Yes. Okay. Welcome to all to our Neurophysiology and Cognition Lab of Department of Sports Science and Yoga. I am Sanjay Majhi. Now I am going to demonstrate the Neurophysiological Assessment of EEG. So our research objectives are to understand the neurophysiological correlates with the sports performance or the body-mind interventions. So in this session, we will demonstrate tasks on a subject who is sitting on in front of a desk and who is given a task that is called the computerized modified stoop test. This test is given a task of word named red, blue, yellow, and green, and which is represented in different color, incongruent color. The subject is advised to see the screen and which color is shown in the screen, and then he have to press the respected button. And this tube test is modified, is custom designed, and our aim is to monitor the inhibitory control of the subject. So let's begin the EEG session. So as we know, the EEG is a device which can monitor the postsynaptic electrical activity from our brain of our scalp, and it also used to monitor the depth of the seizure and sleep apnea and epileptic seizure. Let's we start the EEG session. Come.
Actually, I am not the doctor. I'm the assistant professor in this department. So our aim is actually working on different cognitive domains. Like we know that sports performance is probably the highest physical demand. We need a brain, very capable and working brain in order to work. So we actually work on different kinds of cognitive domains like pre-attentive phase and attention, working memory. Inhibitory control is also a very important phase. Suppose a player in a cricket match is going to throw at one end, right? And he's looking at that end. But if I look on the other point of the pitch, the player there is far away from the crease. So if he stops it, and that's the inhibition in the sports, the spontaneous comes and he throws into the right end. So similarly, different things also work out. So it's not only the player who is also having the maximum physical ability or cardiorespiratory ability, how his brain is functioning. So these are the aspects, and we also try to do some of the social experiments. So our strength is actually from the electrophysiological aspects, we record EEG. We know that EEG it defines different wave patterns. So it is quite clear now that, okay, it is useful to understand from the clinical aspects, the depth of anesthesia. We can also study the ischemia, hypothermia, even we can call it the perioperative neurocognitive decline, and epileptic seizure is a very common. But for research use, we can do a lot of things, wide spectrums of analysis, like how the brain activity or the wave patterns, whether there are kind of synchrony, desynchrony, or if we go into, because EEG analysis from another point is a very different aspect. It's a very, I should say a very intricate and complex aspect, how we want to treat your or analyze your wave. So there are 4 different modules of analyzing. We all know one is the frequency domain, we can analyze the data. In the time domain for component analysis, we can analyze the data. We can use both the frequency and time domain, and we can also use the nonlinear methods. So this is definitely a different chapter. So for this demonstration, what Sanjoy will show you is that using the international 1020 system. So we have this system, you can see this is actually the passive kind of acquisition. We have these weight electrodes, and this is the head box, that's the acquisition and the amplifier module, and this will be the software. So what he will do is that in the 1020 systems, he will show you the markings that how we have to do in order to acquire the EEGs, but he will probably do it from the frontal aspects of the brain, because we know this, the frontal region, it plays a very vital role in human cognition. And there is definitely perceptual areas also, but for time constraint, we are not going here. So we will do he will place the electrodes on both sides of the hemispheres over the scalp. And then we will do a cognitive task. Stroop test is something like, we call it an inhibitory control, how good one's inhibition is. Because this task is very old, and it was something like, we have been given, suppose 4 colored words, we all know, but those color words, if
the name of the colors matches with the color inside, that means those words are congruent. But if I am say writing red, but the color is of the word is yellow or blue or something else, that means it's an incongruent. So in this task, what will happen is that the subject, he has to click. So we have, why we say it's a modified, because we have altered it into a motor activity. He does not have to give a verbal anticipation. What he has to do is that there are those colored keys according to the color inside the word. He has to click it, and these incongruent words will be intermixed with the neutral words. So neutral words with different colors. So what will be the aspect? The aspect will be, he has to, the subject, we will record two things, that how much correct attempts he is doing and what is actually the reaction time between the congruent and the neutral trials. So in this kind of cognitive tasks, these tasks are actually custom designed. So we generally make our codes and we run this whole thing. And we just can play it with different kind of interstimulus interval. For any kind of cognition, I have to say that we need to know there are two things. One is the stimulus onset, stimulus duration, and the space or the time between the successive stimulus. We call it the interstimulus interval. So we can play with that. We can play with the stimulus duration and we can get the Eeg. Eeg is one aspect. Another very important thing is ERP, that is event related potential. So we know that from the onset of a stimulus, there are different kind of processing, information processing that runs in our brain. And this we know, if we can go through some are the negative waves, some are the positive waves, we call is P300, there is positive 300, N100, there are many waves. So if we go into this wave and study this, we will see that the waves which are later in the time points, they will show the later processing, brain processing, later stage of brain processing. That means if we start from cognition, the first thing which comes from the onset of stimulus, can I say what it will be? Anyone? The pre-attentive phase. Suppose you are all now focusing on it. Suddenly, if a sound, loud sound is heard outside, we will turn our gaze into that. That doesn't need attention. That needs something like turning our gaze. So this is the pre-attentive phase. Next, we attend to what it is happening. Then we execute. So these are actually this time, these events which are actually time-stamped events from the onset of stimuli. So if we can gather these timestamps and we can study between different types of group, or even by changing different kinds of trial, we can understand that how these brain activity patterns and the ERP, they are correlated. So let's now start. I think you have understand this. Okay.
So now I'm going to demonstrate the measurement of 1020 system. It is a basically international standardized 1020 system. In this system, the point where the nasal bone is started, this is point the nasion, and behind the occipital lobe, and the occipital bone here has a neutral line. This point is called the inion. From nasion to inion, if we consider the distance is 100 centimeter, then in 1020 system we have to divide the some amount of division. The first 10%, the first division would be 10%, and then next division would be the 20% of the total distance, then the next would be the 20%. So here we get the midpoint, the 20, 20 and 10. This is the 50%, mean the 50 centimeter from the anterior part. And the posterior part, we can say in the same way, the distance will cover the 20, 20 and 10. So here we can get the Z line and the mark as follows. And here a point, the pre-auricular point, and this is the left side and the right side. And from pre-auricular point to another pre-auricular point, we have to measure the length. If we consider that it is the 100 centimeter, as we resemble that the distance is 100 centimeter, then the first part it would be also the 10% of the total distance. Then second part would be the 20% of the total distance. The another third part is the 20% of the total. So here I can get a point which is the midpoint of this line. So here the 20, 20, 10, and the another part would be the 20% of the total, the 20, 20 and 10. So here I get the midpoint of the scalp, and here I divide the two lines, Z line and the another line. And here from the half circumference of the head, we have to measure the from 10%, where I in the Z line, we get the 10% point. This is the FZ point. From FZ point, we have to measure the inion, from FZ to inion point, and from inion to above 10% is the OZ point. So we have to measure the FZ to OZ point. So if we consider this is the 100 centimeter, then it would also be the 10%, 20%, and 20%. We get here the midpoint and another 20-20. So that is why it is called 10-20 system, and it is standardized because it is equal distribution according to subject, head, and shape. So now I start to measure the 10-20 system. This is the measuring tape. It would help to get the total length of the scalp and total length of the Z line. So here, this is the point, the nation. Here I have put the point of the measuring tape, and here I got the point, the bulge area, which is called the inion. So total distance is 36 centimeter. So here I have to mark the point would be the 10%. So 10% is the 3.6 centimeter. This is the 10%, and from 10%, the 20% area is 7.2. And from here, the another 7.2 centimeter. This is the CZ and the midline. From here, I have to bring the another 50% area, 7.2, and another is 20% is 7.2, and lastly the 10% of the Z line is 3.6. So here I will mark the Z line, and I have to now mark the preauricular point from starting from a left preauricular to right preauricular point. So here the distance is 34 centimeter. Okay. So at first I have to mark the 10%, 3.4. From 3.4, I have to measure the 5 point. And it's 20%. Then another 20%. Yes. Here I got the CZ line, which is the intersect of the two lines. Here the another 20%. This is the another 20%, and lastly this is the 10% of the. So I have here I got the two line. Now I have to measure the half circumference of the scalp. This is 29 centimeter. The 29, 2.9.
So for half circumference, you are measuring from prefrontal midline to occipital.
Occipital, yes.
So it should be in the middle.
Yeah. Now I have got the 6 centimeter. The another 20%, 6 centimeter. And this is the midpoint of the half circumference. Here another point. And last 10%, 2.9 centimeter. So I have totally marked the places where I'm going to place the electrode. And before preparation of the 1020 system, I have asked to the subject that he has totally washed his oil or grease from his hair or not, and he is sufficiently take his bath or not. This is the alcohol and it is the swab. I have to put some little bit of alcohol to remove the grease. If remain some grease or the dead cells are there, then I can remove from here. Yes. Yes. Now I have to make the gentle abrasion. This is the point FZ, the Z line and the frontal area, gentle abrasion. And this is the CZ area. I have to remove the dead cells and the oil, grease are the if it is present here. And this is the point of 7, F7. Yes. I prepare the area for electrode placement, which is help to better conduction of these electrical impulses. Now I am going to place the electrode as marked in this area of the scalp. First, I'm going to place the electrode FZ. This is an adhesive gel, which is help to it has also nature to paste and it hold the electrode with the scalp. Yes. Now F4, I'm going to place the F4. Sorry, F3. Yes, yes, yes. Sorry, yeah. Left side is a odd number and right side is even number. F3. Last F7. Then T3. Here from the preauricular point to 10%. This is the T3. Now I have to fix this wire, otherwise it makes a noise in our EEG, and it also hold the electrode with the place, help to hold with this tape. I can stick the wire with the neck area, backside of the neck area. Now C3, I'm going to place yes. Now I am going to place the right side of the skull. At first, I have to place F8. Then F4. Then C4, I'm going to place the electrode. T4. The T4 area, which is the 10% of the total length from pre-auricular point. Now I'm going to place the A1 and A2, which is we have to be place this electrode at the mastoid facet, behind the area of the bony area of our neck, of our ear. The mastoid process, the A2 area. Yes. Yes. Different. OZ we are going to place the reference line. This is the A1. Yes. Yes. Now going to place the reference area, which is the OZ, the midline of the occipital bone, the Z line, and the which is intersect of the occipital lobe, OZ.
I must say one thing here, referencing plays a very important role where we are placing our reference. If we are interested to look out the waves from here, it's better to go to a different side because there will be the same kind of symmetry, because there are three things we have to. One is when we are acquiring the wave, so the calculation is the recording electrode minus ground minus reference minus ground. So the ground interference cancels out, and whatever we are getting is the recording electrode minus the reference. So we can for now take on any kind of referencing. If we are measuring from here, we can take it somewhere far away from these areas, and then we can use re-referencing, like we will use this A1 and A2 later on from both hemispheres, either hemispheres, and make an average, and from there we will take the differences of its recordings. So there are different kinds of roles we can play with references, and we can check our data also, right, that how we are getting these waves.
And lastly, I'm going to place the ground, which is just above the eyebrow. Yes. Just I press the electrode that it can better attached with the scalp area. And paste the wires with the neck, and it helps to remove the loose connections. Yes. So it depends upon So I have finished the electrode placement according to 1020 system, Now I am going to giving a task, the subject who is advised to stoop test to see the object, see the word and which color is filled in the word, and he have to advise to press the suggested color. Okay.
So I tell you the two noticeable things that come is the alpha and the beta. Definitely, because this gamma is something still doubtful. I mean, people say that we are getting gamma. Just listen. I mean, if we think that placing an electrode over the scalp and we were thinking of high frequency wave, there's so much of interference and so much of distance. So the most conspicuous things or noticeable thing that we can infer is actually within the from delta to the beta range. I practically see, because I have the experience from recording from a single unit of neurons trying also trying the local field potential. So there we find it, but from a distance where there are other noise interferences, high frequency waves are something questionable. So anyway, so now you can see these are the eye blinking artifacts. This big close your eye, open your eyes or blink your eyes. Now if you close your eyes, so you can see this rhythm, so noticeable. Now open your eyes. It's gone. It's now becomes small, low amplitude, high frequency. So these are the things. So practically, that is what we want to see during sleep studies. How a person individual is going to sleep and look at the rhythm. So now you look around. Place this there. So this is also a very important attachment. We have made it in order to see these eye blinks and with hear the waves. So we can say that what is happening, what kind of artifact it is. So it is very important. So, for the Stroop test, it is now clear. So the stimulus interval, interstimulus interval is set at 1.5 seconds. Stimulus duration is 0.5 seconds. And he will try for 48 trials. So let's start, okay? So I put it here in the recording mode. So this is another important thing, the events, when I am triggering the event. So this is very important to get the timestamp from where the study is beginning. So these are some kind of adjustments I made. There is the mirror I can see here through the mirror, the screen. So I can look at it. So now, okay. So here he's getting this instruction that press the key matching the words, right? So now I am using this trigger for now manually, both pressing this button and the trigger together, and I will get the timestamp. You can see here the timestamp. So here the experiment starts. So if there are kind of movements, we will get some artifacts. So we have to check, and these are very common. We have to remove these channels. Eye blinking is there. So he has to fix on that. I don't know whether you can see. Some of you can come from here and can look at it. If you, yeah, please. You have to see the test actually. You can go. So you can see that's the crosshair. The crosshair, the subject has to look at the crosshair, and now he has to press the color inside with that color coded key. So depending upon different kind of interstimulus interval, press the color yellow. Here you used to press the color red for the grade. So this is the conflict that happens. We usually pronounce grade. So that's the immediate conflict. And you delete and put the command that is how fast you can do it. That's the reaction time. So these are the words which so now I show you what will be the result. So these are the real time or healing. You can look there.
Yes.
So you can see here. So please. So these are the attempts. So this pie chart diagram show that he went one is incorrect attempt, right? And this is actually the time in the y-axis, the reaction time. Okay. So usually for incongruent words, the time will be taken more. Okay? Generally, the conflict is more rather than neutral. So you can also play with the congruent, neutral, and we can find out what is the difference. So the y-axis is the reaction time. Then how fast from the onset of the stimulus is being instructed to press the button matching the color inside the button. Yeah, the y-axis is actually the time. So you can see it if I so you can see it here, right? That's the reaction time. So you can play with different number of trials. You can see the sustained attention there, how long one is attending, how you can change the interstimulus interval, just say the person to respond as quickly as possible, and you can see that how many correct attempts he does. So how is his inhibitory control? And then we can relate it with we can just take this data, we can do both the ERP and the Eeg analysis. But that's a lot of things. So this is not possible to do this. Okay, so if you have any questions, because for the cognitive experiments, we have to take this data offline, we have to analyze, we have to do the pre-processing, and then we have to see from the time domain and frequency analysis what's coming on, right? So what you can get right now is the psychophysical data here, and then we will take this data and we will do the analysis. So this is what about. Okay, thank you. If you have any questions regarding the placement of electrode, do we have some time? So we can take the questions. So nowadays they are using active electrodes and dry electrodes, because EEG now it has become a fascinating thing. When people are using electrode, it's this kind of head maps, and there's one electrode attached, and they're just doing neurofeedback. It's very more for patients who are suffering from anxiety syndromes. So we can show some graphic interfaces, some music, and we can say that just make that graphics or interface with the brainwaves, and through the brainwaves they can guide that okay, you can keep your relaxation. Yeah, more than you can see hear good melodies. So this is how the whole thing gets interfaced. So another good thing about is dry electrodes are that and the active electrodes, the amplifier is placed here. So the main thing is they're getting the signal to noise ratio much higher. So since the amplifier is outside here, so if the subject moves, if the wire moves, then we will get the movement induced artifacts. So that's also the scene. That's why the camera should be also on in order to see what is happening.
You know, when you are used to train using your before it's training or you try everything and for train decisions for you need this type of feedback from how you are trained to relate acting.
Okay.
So we train this way.
Okay. So there, it's working, right?
Yes.
That's working.
He's not sure it has properly, but that is the only way that it has worked or not. But it was one of those methods he tried, and he said we got results from it.
Yeah. So neurofeedback is actually the next, because what we are doing in the neurofeedback is just playing with the power of the alpha and beta. We are taking that algorithm, we have built an algorithm, simple. We are taking it through a timestamp. Okay, for 1 second, we get that power, make the ratio, and then according to that, you change the interface. This is how the things run. And that's all easy to do actually, and very effective. But you have to first find out what kind of task and what is the reference, where you are getting. So basically, we have shown it for the frontal, but for the interbrain is actually needed. Okay, so any other questions? Thank you, Sanjay, for
Yes,
your
sir.
excellent demonstration. Arnab, can you start? Can you proceed?
Yes, thank you, Arkadeb, sir, for this. Am I audible? Am I audible? Anyone?
Yes, sir. Yes, sir. You are audible.
Okay, thank you. So thank you, Arkadeb, sir, for this wonderful EEG demonstration, and Sanjay as well. So now we'll move to our next session, next event, that is exercise physiology lab and assessment of aerobic capacity, that is VO2max, assessment of anaerobic power, that is maximum power, peak power, average power, and minimum power. And along with that, we'll see the post-exercise recovery response as well. And as I mentioned, two other pillars, that is strength and flexibility, we'll see. So now we'll start the session at within 2 minutes. Please be online. Just we need to give us some time to set up this area and to participants to come from another lab to other this lab. So just 2 minutes time. Give us 2 minutes time. Thank you, all of you. So it's 11:35. We'll start at 11:40.
পেন আছে আমার কাছে স্যার একটা ছোট কাগজ হবে হাইট ওয়েটটা জাস্ট দেখানোর জন্য লিখছি হ্যাঁ
Go through the welcome to the exercise physiology lab. So am I audible clearly? No. Okay. So as you can see, so this station is basically designed such as I mentioned in exercise physiology, basically we emphasize on 3 to 4 pillars. One of such is first strength, endurance and power, along with that agility and flexibility. So you can see the first station is just when an athlete will enter, the first station are designed as body weight and body composition assessment, followed by flexibility assessment and strength. Then this is the cardio session, cardiorespiratory fitness assessment station. So just now we finished the brain waves and mental neurocognition lab part. And here we'll mainly focus on heart and lungs, basically. So when someone is doing exercise, or if someone is doing training regularly after 1 month or 2 months or whatever, how the adaptation or what kind of adaptations are happening in cardiorespiratory system, those things we can measure here. And this station is basically after endurance part. So this cycle is purely because of for the anaerobic power assessment. So as I mentioned, so there are several field protocols as well to measure Vo2max or to measure anaerobic power. But in lab setup, the best part is in a control environment, we can test the whole thing. And when we'll assess the data next time to interpret for interpretation purpose, it's much easier because the confounding factors are very less, like humidity, wind speed, temperature. In outside, we can't control this because if we are assessing after 4 months, obviously the climate condition will change and it will be different. So that may affect the physiological status as well. So here Devobroto and Devduhita, they will explain. Devobroto will explain the cardiorespiratory portion fitness testing, and Devduhita will explain the anaerobic power. And after that, we will see the basic strength and flexibility portion. Okay. So over to you, Devobroto.
Thank you, sir, for the good morning. I am Devobroto. I am the register here. Now am I audible? Okay, thank you. So good morning everyone once again. So here it is basically here we will assess the Vo2max in terms of some graded endurance exercise. And myself Devobroto, I am the demonstrator here. Along with me, Devduhita will assist me, and our senior Subhadip will volunteer for the exercise session today. So let's begin. At first, you should know that what is graded exercise. Graded exercise means where the exercise load or the hardness of exercise increased after a certain time interval, and the load just goes like a staircase like fashion. After a certain time, you have to increase the load. That is known as graded exercise. So basically, the subject will perform the graded exercise here in the treadmill. and we will assess the VO2max. Now the question arises that what is VO2max? So VO2max is that maximum level of oxygen a person can utilize during a maximum volitional level or all out effort during exercise. So it is known as also the maximum aerobic capacity of a person. So we will measure this today. So for measurement of VO2max, we need a sophisticated equipment. Luckily in our lab, we have a equipment, it is known as COSMET CPET. So the full form of CPET is cardiopulmonary exercise testing. That is why the machine is commonly known as CPET machine just. So you are seeing this white box. So basically inside it, there are several O2 and CO2 sensors, and along with it in the behind part, there is a gas cylinder, and there is another part that is called the turbine, and along with it a sample line tube, this hollow white tube, it is called a sample line tube. It is coming from the back side. It is also there. So basically these all are the hardware part, and the software part is installed in this PC. You can see there. It is known as COSMET Omnia software. So we have to just log in the software before use. Yeah. So before assessment of VO2max, we have some pre-assessment procedures. Among those, first one is you have to just power on the device at least 30 minutes before the exercise session or taking any kind of measurement, because it is needed for the warm-up purpose of the machine. Without proper warm-up, the machine may malfunction, or the data shown in the device may hamper, it may change from the actual data. So warm-up is very much necessary for that, and it is already powered on in today's morning, so it is already warmed up. Now we have to do another process that is called as calibration of the machine. So for calibration, we need 3 types of calibration. So you can see here a calibration option is there available in the software. I have to just click on this calibration. Inside it, for this device, only 2 types of calibration is needed. There is flow meter calibration and gas calibration. Now, inside gas calibration, there are 2 types. One is metabolic calibration and another one is air calibration. For metabolic calibration, now coming to the point, what is metabolic calibration? The metabolic calibration means where the machine have to detect that how much amount of oxygen or how much amount of carbon dioxide, means that % of oxygen or carbon dioxide. The machine has to detect it very precisely. For this, the metabolic calibration is needed. And for metabolic calibration, the gas cylinder behind this machine, it has a fixed percentage of O2 and CO2 and other gases. So already we know this. So we have to just
interrupting. So if you see that cylinder behind, I don't know the other side can see it or not, it's behind. So that cylinder, it's a certified gas. So the concentration of oxygen is 16% and the concentration of CO2 is 5%, which is compared to a normal air, the O2 concentration is much lower and the CO2 concentration is much higher. Okay, proceed to it.
Okay, thanks. So so after the metabolic calibration, the machine will detect that this much % of O2 and this much % of CO2, means this much air, or this much air, inside this much air, this much % of O2 and CO2 is present. So metabolic calibration is needed once or twice in a week. It is good enough for that. So already we have metabolically calibrated the machine 1 day ago, so you need not to do that today. So for metabolic calibration, you have to just click on this, and if we can click start, then it will show some kind of instruction that you need to just on the stopbox so that the gas can come to the machine, and you have to just detach the flow meter tube from here and sample line tube from here, and you have to attach it in the another port. Then you can start and the machine will automatically metabolically calibrate it after some time. Okay, so we need not to do that, so I am clicking cancel now. So the next part is that air calibration. For air calibration, now why we need the air calibration? So ultimately, when the athlete or subject will exercise, he will take air from the outside environment. So it is also very much necessary to know that how much % of O2, CO2 is present in the current environment. So for that, air calibration is needed. In this process, machine will detect that how much % of oxygen and CO2 is present in surrounding environment. So I am doing this in front of you now. So if I can click start, then it will show some kind of information. It is showing that you have to first detach that sample line tube from the turbine, and you have to just keep it aside so that it can, so that the environmental air can go through the sample line tube from the behind side, it will go to the machine, and with the help of the O2 and CO2 sensors inside the machine will detect that how much % of O2 and CO2 is present in the air. So I am just clicking on OK. And now it is better to maintain at least some distance, because my exhaled CO2 can hamper the calibration process. So let's wait for that. So now the air calibration is going on, and the machine takes the air from the surrounding environment, and automatically it will detect that O2 and CO2 % in the current air.
So basically that sample line tube is a hollow tube with a nozzle, and inside behind that, in the hardware part, there is a pump. So pump will start, so you can hear a faint sound like this. A pump is running. So it will suck the ambient air and it will detect. So the air through sample line tube will enter, it will go to the O2 sensor and CO2 sensor. And then, so the O2 sensor here in this equipment is beautiful, that it's a paramagnetic sensor. So in most of the metabolic gas analyzer, particularly the portable, we will also explain. So there, after every 6 months, you need to replace the O2 sensor, which is again means that will come from abroad, and it's a commercial process in the paperwork and all that. But here it's a paramagnetic sensor, and until and unless some voltage related something happens or some damage mechanically, then only you need to replace it. Otherwise, this is the beautiful part of this O2 sensor.
So it needs some few more seconds to complete. Okay, now it is showing that the overall result is passed. Now we have to just click on the accept, and now I have to just reattach the sample line tube with that. Sorry. Now that air calibration part is over. Now I am proceeding to another type of calibration, that is the last calibration today. This is called as the flow meter calibration, or it is also known as volume calibration. For this, a syringe or cylinder is needed. This is that white cylinder is here. So okay. So basically what you have to do is that with the help of this hollow tube, you have to just attach the cylinder with the turbine, so that when we just, it is like a syringe, this cylinder, you can just pull and push this, and the total volume of the syringe is 3 liters. So when you push this, it will just mimic like a condition that a person is exhaling, and when you pull it, it is mimic like a condition that person is inhaling. So I have to just attach this hollow tube here, and the another part I have to attach with the turbine. Sorry. Okay. Now it is all set. Okay, now you can click the start, and I have to give 6 strokes here. So I have to try to maintain the same rhythm as far as possible, so that there will be good calibration. I have to gently pull till the end, and then I have to gently push till the end. You can see that graphs are started to appearing, how much volume is going and coming. I have to repeat this process for total 6 times. So we have seen that the overall result is passed, and we can just accept it. And now the calibration part is over. So we can, yeah, you can also do.
Or can we proceed? Okay.
Thank you. So you have to just detach it. Now the calibration part is over. Now we can proceed to the main testing part. So for that, we need Subhadip, please come. Where is Subhadip? Sit here. Okay. So before his actual measurement of Vo2max, we need some basic information about him. So basically, we have to do his body weight and height. We have to measure. For that, we have a body composition analyzer. Please go with me. So in that body composition analyzer, please remove your shoe and socks. No, not this one. This one. Yeah, you also. So as Sir already said that this machine mainly works in a mechanism that bioelectrical impedance, and infrared ray comes from that upper side and automatically it detects the weight and height. You can see that weight measuring is going on. So please note that his weight is 80.3 kg.
For full body
So
composition.
176.2
You can do the
centimeter.
full body composition as well. Proceed.
Okay. So as the machine instructs, you can just click on the next button and hold up the holder and press the button.
Take the printout as well.
Sir, I think paper is not inside.
Okay. Fine. Paper is there. You can take a printout. Or the entire data through a pen drive, we can transport it to the system. Yeah. So there is a designated software IOI in the system.
Press next. Oh, it's so now it is measuring the actual body composition, his total fat percentage, his muscle mass, everything will be displayed. So you can see that all things are displayed here. His weight is 80.3 kg, and you can take a printout as well. It is printing, this going on. Okay, we can set transfer it to the pen drive. Some printing error is.
6.2% of body fat.
Yeah, and standard weight should be 68.3 kg. And his B, yeah, and it is shown that is little obese.
Okay, leave it.
Okay.
We can transfer the.
Okay. So coming back to the next part.
So basically like a ECG paper, so it will come, the entire data, whatever is shown there, he's trying to replace the paper roll, so it will come. Okay. And parallelly, how many data it can store? Approximately 50 to 100 data, most probably. So the whole thing, if we insert a pen drive without selecting any option, the whole data will be transferred into the pen drive, and whatever the system you have, but you need a software, this equipment compatible software, that is IOI. So if you have that, so multiple times, if a person visits twice, thrice or more times, so in that profile only, the whole thing based on that ID, the whole how many visits are there, so entire thing, and you can compare the data easily. Okay.
So I think he's trying to create. Okay, but I need him for demonstration now. So wait for 1 or 2 minutes. So what's that? Please come now. After wearing shoe, you can come. So before proceeding to the main process, we need some basic information from the athlete or volunteer, that how he is feeling today. Is there any injury among in any type of his muscle injury? You are feeling comfortable now, and any type of injury is there? Okay. And another questionnaire is given already in your handout. You can check. That is
most probably the PARQ questionnaire is not there, so we'll provide it to you.
Okay, it is not there. So it is known as PARQ questionnaire or physical activity readiness questionnaire. Inside this, there are also some basic questions like, do you smoke or do you have any kind of injury, when last you have consulted a doctor? This type of questions are there. So he has already pre-filled the questionnaire and all the test is okay. So we can proceed to the next part. So for that, you need to warm up before starting the endurance exercise. Just do a 3-4 minute running, little jogging and little cycling also, and some basic stretching. Okay, you go to the outside and you can do a warm up. So meanwhile, we can just create his ID in this software. Before every new patient or new participant comes, you have to just create his ID. So I'm clicking on the testing part, and now for a new subject, you have to just click on new subject, and here you have to just put the basic information about him, the ID number, his name, and etc. And when you will click save, automatically the ID will be created. As he has done this test in this machine previously, so his ID is already created. So after clicking that, I have to just click on the new visit, as today is his new visit. Now I have to give his updated weight and height. So what was his weight today? 80.3 kg. I have to update it. Previously his weight was 81.9 kg. And his height is 176 centimeter. Okay. Now I have to just click on save. And now I have to just click on the new test and the test will begin. So let's come to another point. This machine is basically a stationary model of machine, and another type of machine is also available in the market, that is called as portable machine. So obviously one difference between those is the portability, and another difference is that basically the stationary model is used in the laboratory setup, where in the air conditioned room, in temperature and humidity, all the things are maintained. But in the in-field condition, the portable machine is used where environmental other factors needed to be considered when calculating the results. So we need not to consider that, as all the things are maintained here. So after that, we have to just go to the protocol. So I have to just click on the new test. So we will obey today a protocol for graded endurance exercise that is known as Bruce protocol. It is developed by Robert Arthur Bruce in 1963. He is also known as father of exercise cardiology. So the inside Bruce protocol, you have to just maintain a fixed speed and inclination in a treadmill. So you can see that this is already written here, that there are several stages till the full exhaustion of the athlete. You can continue in the stage number 1, starting from the 0 minute. The speed will be, at first the speed will be 2.7 km/h and the slope will be 10%. And in the next step, gradually the speed and slope will be increased, and till the athlete will be fully exhausted, you can just continue the test. So basically there are several protocols also, like Bruce protocol, modified Bruce protocol, Balke protocol. So for different population, we can choose that what test is appropriate for him. Suppose for a highly trained athlete, the Bruce protocol is not so good, because it will not, it is seen that in 4th or 5th stage also, there is no such changes in the highly trained athlete's heart rate or VO2 max. So it is already, it is only for sedentary population or for little trained population. So we are obeying this protocol today. And for that, we need some other equipments as well. So first one is, this is called the heart rate monitor along with that binding strap. So this is already I have attached one heart rate monitor along with the subject's body. So this is the main part is here. So it is called this heart rate monitor and the binding strap is here. So with the help of hook, you can just bind it with the subject's body, and this heart rate monitor means the monitor part should be in the close to his heart in the sternum position. So that the machine can easily take his heart rate and can show the actual data. So inside testing, by using this machine, we can do various measurements other than this cardiopulmonary test. So one of such is inside spirometry. You can see there are various tests. So force vital capacity we can measure, force vital capacity, post dilator also we can measure, and some clinical tests also we can measure. But mainly we focus on the sports related test. So today we will do his inside the metabolic portion. We can also do his resting and energy expenditure measurement. So today I am clicking on the cardiopulmonary exercise testing. Inside it, we will do to the CPET breath by breath. So now why it is breath by breath? Because you can see when the test will be going on that the machine will show the data in every second. In every breath by breath, the machine will measure that how much % of oxygen he is inhaling and exhaling, how much % of CO2 also he is inhaling and exhaling. That is why, and it is very necessary to accumulate the data for further analysis. So every second data we need to detect his various components precisely. So for that, I can just click on the CPET breath by breath. So before starting in the actual measurement, we have to use the mask for taking the volume of air the person is using during exercise. So we have 3 sizes of masks here. You can see this is the extra small size of mask. You can see here that this is written as extra small. Yeah, you can see the extra small is written here. Okay, and another 2 sizes are also available, that is small size and medium size here. So according to after looking the athlete's means shape of his mouth and head portion, you can just select it and ask the athlete that is it this size is comfortable to you or not, and accordingly you can just change it. So along with it, a head strap is also there to bind the mask along with the athlete's head. So this red part of this head strap, I am just detaching it. This red part of the head strap will be in contact with the athlete's skin, and this gray part will be in the outside portion. And you can notice there are 2 circles here. One circle is big and another circle is small. So the big circle will be in the upper portion and small circle will be in the lower portion. Okay. So please wait for the athlete to come. So you are warmed up completely? Okay. Now we can proceed for the actual test. So basically we have to do a graded exercise where in every 3 minutes we have to just increase the load and inclination. You will find a little harder to exercise in every 3 minutes. And when you will be feeling like you are completely exhausted, just raise your hand or ask us. Then we can immediately stop the test. Okay. And your shoe laces are tight now, and you are feeling comfortable now. Okay. Now I am attaching the mask with his mouth. I think the small size is perfect for him. So we have to just, with this help of button, I have to just attach it and just pull it so that the sound appears and it is locked. Here also. Please close your eyes. Is it comfortable to you?
So basically in any kind of exercise or particularly graded exercise test, the pre-test procedure is very vital, particularly knowing about the athlete's health, wellness. If it's a clinical population or somebody is having some injury or in rehabilitation and you want to do the assess the fitness profile, so then obviously the PARQ questionnaire or those kind of questions needs to be filled. And another one part is what we are going to do and why we are going to do this. So that protocol, it should be clearly mentioned or instructed to the athlete first, that after 3 minutes, although it's a Bruce protocol, so athlete may not understand every time that what is Bruce protocol, what is modified Bruce. So they will understand what they actually need to do. So that instruction should be very clear to the athletes, that after every stage you need to be centrally placed, you should not come back in the treadmill. So whenever an athlete is on the treadmill, it's everything is on your responsibility. So that if any kind of injury happens, so the athlete may finish the career or something means based on the severity of the injury, anything can happen. So better whenever such kind of testing is there, particularly graded exercise test, initially maybe the load or intensity is less, but when the speed or gradation or the stages will increase, the severity of the speed or maybe the inclination will be very high. So if something happens that time, so the safety precautions and the instruction need to be given to the athletes properly. And when to stop the testing. So can you please explain the when to stop the testing? The test will over.
So one thing I want to add, sir, that in the case of athlete, it is not so vital, but in the case of clinical population, when they do such type of test in a low intensity, it is very vital to notice his heart rate and his RQ value every time, because it is advised that his heart rate should not go up to his maximum heart rate, which is measured by a formula 220 minus H, and it is to be noticed with extra care so that any kind of injury should not happen. So now in case of him, I should just, can you please exhale one time? Now inhale. Any type of air is leaking. Okay. So if any type of air is leaking, we have to just tight the head strap by using this. Now please exhale one time. Now inhale. Air is leaking. No. Now it is perfectly tight. If after this also the air is leaking, then you have to change the size of the mask. So now it is completely okay. You can just come to the treadmill. And as Sir was saying, that when we have to stop the test, when the one point is that when the athlete will raise hand, we can stop the test. And sometimes it is also seen that the athlete cannot raise the hand, or he just feel that he can do some extra time, but it is actually not. So we have to just notice his stepping. If irregular stepping is going on in the later stages, we can just stop the test. Or RQ value is going so high, greater than 1, then we can also stop the test. Now I am attaching the turbine with his mask. So please come. Sorry. Okay. Now it is completely locked and he can start the exercise. So if we can just start this, the exercise will start. So you can just go to the treadmill and try to always remain in the front side of the treadmill, and 1 or 2 can also assist here. If you can just assist me. Anyone is interested? Yeah.
What kind of assessment?
Yeah, I am telling that if he, after some time, you are looking that he is coming in the back side, you have to just resist him for the safety purpose only. Okay. So I am just clicking on the start, and then I have to just click on the protocol we are maintaining. So today it is Bruce km/h protocol. There are several other protocols we can also set manually also. And the treadmill is not interfaced here with that software. So we have to manually just increase or decrease the inclination and speed. So there will be 1 or 2 seconds error, but it is negligible. So we can just, here we can just click on OK. and it takes a little time to start. You can see that after 1 or 2 seconds, the data will come in this portion.
I think it will be better if we share that screen to the audience, those who are attending online. Is it possible to make it? Just 1 minute before starting, we'll minimize it and we'll share.
I
the
can
whole
abort
screen.
it now.
No, yes, for the time being, just it will take 30-40 seconds. So for the online participants, you can just change your tab to see the actual Cosmet Omnia software that is already shared. You can change the tab. So one side you can see what is happening in the going on in the lab, and another field will be you can see in the software how the data acquisition is happening and what is running on the software. That part you can see. Just you need to change the tab time to time because you can see, I think you can see in the virtual classroom, there are 2 tabs up there. So you can see, you can change the tab, I feel.
So I am just aborting it and starting a phase test. So when we are clicking on start, you can see that after clicking on the protocol we are maintaining, we have to just click on OK, and then it takes some time to the data to come.
So I'll ask one question to the participants. Can anybody tell what is the graded exercise means? What is the meaning of graded exercise? As he said multiple times, we'll follow a graded exercise for the protocol. No, that is an interval kind of exercise.
No, with respect to time.
with respect to time basically. So obviously if the intensity is increasing, obviously the load or stress will be on the physiological system and other parameters as well. So basically, so there are different types of exercise. One is the steady state exercise. For example, an athlete or a person is running maybe at 6 km/h, or evening somebody is jogging or running at the same pace for 30 minutes or 40 minutes. It's a steady state exercise. It's an incremental exercise, or sometimes a graded exercise protocol. There can be different resistance exercise as well with the bands and all those things. Sometimes strength exercise when someone needs to lift the weight and all those things. So like this, there are multiple different modes or different types of exercises are there. Okay, so today this protocol. So why to assess VO2max it should be a graded exercise protocol? Anyone? Any idea? Why we cannot assess VO2max through some other test? Why it should be a graded exercise protocol? Any idea? Okay, fully agree, not fully agree, sorry, partially agree. So yes, exhaustion. If an athlete, for example me, I am running at a 8 km/h pace for 2 hours. After some time, I'll also get exhausted. So that will give a VO2max data. Will it give? Or somebody is running a 800-meter sprint. I said you have to run 800 meters, and within this 40 seconds abruptly, which is practically not possible. Then obviously he will get or she will get evolutionally exhausted. But then
we are measuring aerobic to VO2max. So we have to put that parameters.
Okay. Yes, so Bruce protocol is a gold standard protocol, obviously. So in any kind of graded exercise test protocol, there are certain criteria. So one of such is the graded exercise should be over within 10 to 15 minutes. It should not go beyond that, or it should not be lesser than that. Sometimes maybe every 1 minute I increase the speed for 3 km or 4 km. So it's also graded exercise. But the athlete may get exhausted before that only, maybe at 6 minutes or 7 minutes. So which kind of metabolism we want to trigger and what you are actually want to assess, the VO2max. So this is one. Another one important criteria for VO2max, any kind of VO2max protocol, is the MATES, metabolic equivalent. So MATES, from one stage, criteria says from one stage to next stage in any protocol to assess VO2max, it should be 2 to 3 MAT increase. That means 1 MAT is equal to 3.4 ml per kg per minute oxygen consumption. So that means at least when the athlete is going from one stage to the next stage, the stress or the load should be such that it will increase the oxygen consumption, and it will to maybe 9 ml to 10 ml per kg per minute. Okay, in that way. So if our resting VO2, what is our resting VO2? Anyone? Any idea? Suppose you all are sitting now. So how much oxygen we are consuming now? Any idea about the data? We'll see here. You can start the protocol. It will go. It will keep on going. Any idea? Here only we'll see how much oxygen we consume. So just 1 second. I'll just show you, or you can click on the protocol here. So here you can see all the Bruce protocol, km/h, mile/h, modified Bruce, Norton protocol. If we are some cycle protocol. So as we have selected the ergometer treadmill, so that's why these treadmill protocols are coming. If we select the ergometer bike, so maybe a HP Cosmos high-end bike, Monarch bike, or some other kind of bike, then automatically. So no, the ergometer part, it's a km/h. So it's a any kind of bike go up. So there are ergoline, treadmill go up. So Cosmet bike. So there are different arm ergometer bike not interface. So we can accordingly the protocol will also come. So go to the treadmill not interface km/h. Yes, okay. And the port is metabolic port. Okay. And the heart rate source here you can see it's written. Just click on the heart rate source once. Yes. So it can be a PC software. Sometimes in some treadmill the heart rate sensors used to be attached with the treadmill. So the source can be a ergometer as well. So here the oxygen, this here you put the oxygen belt, that is a sensor, and the receiver is with the machine. Okay, so that the sensor receiver is detecting the heart rate from there. Okay, you can proceed the metabolic.
Okay.
Any question, any doubt till now? Okay. Okay.
Now the data will come gradually. It will take 1 or 2 seconds. Heart rate already started to come.
So it's very obvious that the athlete's heart rate with the mass and on treadmill, it will be maybe 100, 120. Nothing to worry. We cannot wait that it will come to resting at 70. So like putting this many things, obviously the stress level will be more. So it's very rare to get a 70, 80 heart rate when an athlete is on treadmill or any kind of ergometer to assess these things.
So I have a question that why we are using treadmill, any idea? We can use other type of ergometers as well. So today why you are using treadmill? Yeah. No, it can be done in other types of ergometers also. So why we are using this? Yeah, that is also correct. And as we are obeying the Bruce protocol today, so the Bruce protocol says us to run on the treadmill. So we have other types of ergometers as well. One is treadmill and another one is bicycle ergometer. There are several bicycle ergometers here. And another one is that is rowing ergometer. It simulates the action of the rowing.
So rowing also involves the whole body movement basically.
Yeah.
Okay, so rowing ergometer. So basically it depends on which kind of ergometer or field we should choose. The ergometer depends on which kind of game or athlete is familiar with or is playing. If he is a cyclist, definitely will not encourage him to run on a treadmill. If he is involved in any kind of field running or those kind of things, it's better to conduct on treadmill. And if somebody is involved in water sports, then it comes the rowing ergometer. Okay.
Okay, now we are starting the test. Please increase the speed to 2.7 kilometer per hour. Inclination 10%.
So you can see the VO2, it's 780 beats, 780 ml per kg per minute right now, and it's approximately, although it's taking beats by beat data, breath by breath data, so it's the fluctuation is more. But after this fluctuation will be there, but you will see after some time it will be more than 1000, after some time 1500 the average VO2 will be.
And as it is a breath by breath analysis, you can see that in every 2 or 3 seconds data started to coming. There are various types of data. You can see that VO2, VCO2, FeO2, FeCO2, every types of data are coming here, and the graphs are also started to come. And it is the purple line, it is basically the heart rate, that it represents the heart rate, and that blue line you can see this is the VO2, and the red line is VCO2. So with the progression of exercise, we can see how it will change. So currently his heart rate crosses 100, it is 116 beats per minute, and his current VO2 is 1058 ml per minute. So there are two types of VO2, one is absolute VO2 and another is relative VO2. So you can see here, this VO2 here, this VO2 is absolute VO2, its unit is ml per minute. And when we just divide it with the body weight, it will come at relative VO2, its unit is ml per minute per kg. As his body weight is already given in this machine or software, it is automatically detecting what is his relative VO2 time to time.
So at the bottom, you can see now the stage is going 2.7 kilometer per hour and 10% inclination. Yeah. And the next load is 4 kilometer per hour with a 12% inclination. And the current step is 2 minutes, 11 seconds already over. In the right side, you can see the next step. So it will give an alarm who is conducting the test that when you need to increase the speed or the load, whatever the next stage is. So you can shift it to the performance too. We have a 9-panel. So always, so you can see the 9-panel plot as well. So where VE upon time, heart rate, VO2. So VCO2 powered all the data, breath by breath data. It's coming and it's coming the entire page. So this plot is known as, most probably most of you know, this is a Wasserman plot, Wasserman's 9-panel plot. And we most probably read that Wasserman's metabolic wheel or the metabolic gear.
And inclination will be 12%.
You can shift it to the performance tab.
Yeah.
So the first curve is the VO2 and heart rate. So you can shift it to the, change it to the, if you want, VO2, VCO2 versus time as well. Okay, yes. So you can see now the blue line, it's the oxygen consumption. Now oxygen consumption is more and VCO2, the red line of carbon dioxide production is less. So after some time we'll see when the intensity increases what happens in our physiological system. So this is the response. So basically the goal of the lab or any kind of experiment is, so now we are focusing on physiological aspects of the yoga. One aspect we are currently thinking. So during different yogic exercises, how the physiological system works. Another one, there are several works on several sports person or the population, that what is the VO2, how the kinetics of VO2 during an actual game or event. But the reason or the molecular basis of that response is still unknown. So that is our another goal which we are currently working or planning to work basically. So you can see RQ is approximately 7.75. So which is quite less and it looks like you can go more obviously.
And when RQ will be greater than 1, it means that CO2 is greater than O2. You can also detect from the curve that when the red line will be in the upper side of the blue line curve, then the RQ will be greater than 1, because RQ means VCO2 versus VO2. So currently his heart rate is 126 and he can do at least 3 or 4 stages extra. So we will proceed to the next step after 50 seconds almost. And in the next step, the load or speed will be 5.5 km/h, and in the treadmill will go little up, that is 14% inclination.
So those who are attending online, you can see the shared screen of the software. There you can see all the data clearly. And here the experiment is going on in another tab. Just please switch between these two tabs. Requesting you all to switch between two tabs. So you can see now the oxygen consumption slightly increased. It's approximately 1,400 to 1,500 ml per minute. Minute ventilation is also increasing. So those who are involved in endurance sports, particularly marathoners, the VO2 value can be more than 70 or 80 ml per kg per minute. Okay. For field hockey or football players, it's little less. And those who are involved in anaerobic type of sports, particularly 100-meter runners, 200-meter or 400 meters, they don't require that much of oxygen consumption. So we'll see how much is coming. So he is a cricketer. Okay.
So as I have clicked on the graph in this position, there is a marker option, and if you can just a point you are just want to look after this exercise is over, you can just mark the point, and accordingly you can just take a printout, and the marker will be also in the printout, and you can just examine it accordingly. And there are several other options as well. The subject is feeling dyspnea, leg pain, and other all symptoms as well. And so time to time you have to just ask the athlete, this, are you okay or not? Right now, are you feeling comfortable? Okay.
So how the athlete is feeling during the test? So we have a Borg scale. It's called 20-point rate of perceived exertion. RP scale is there. So in which we can assess or you can score by asking questions, how you are feeling out of 10. It's a mild or light feeling, then he can score 4, 5. If it's a heavy feeling, cannot even talk. So that kind of feeling he can score as a 18, 19, what will happen at the end of the exercise. Okay. So when the test will stop, basically, can anyone tell me when the test will stop? When will stop the test? So yes, it's a correct answer only. It's when the subject will reach maximal heart rate. But in endurance sports, we cannot expect the athlete or particularly marathoners that they will reach 220 minus age or whatever the equation of maximal heart rate prediction equation we are following. For example, that means if somebody's age is 20 or 30, that means the predicted maximal heart rate is 190 beats per minute. And most of the time, marathoners do not go up to that level, 190 beats per minute, although their oxygen consumption is much greater than other sports. So we cannot rely only one parameter to stop the test or to understand the volitional exhaustion actually happened. So how to detect that one? One criteria is heart rate. Second one is the RQ. Because in the full field protocol, we cannot see the what is the RQ, but at least we can detect the heart rate. So that is why heart rate is very popular to detect the exhaustion level. But RQ, if RQ is more than 1.1 or 1.5, 1.15, then we need to be very conscious that, okay, we need to stop the test or we cannot push the athlete beyond this.
So we are in the next step now. Here the inclination is 16% and the speed is 6.8 km per hour. And gradually in the next step also it will increase. So as every second's data is coming in the graph, the graph looks like a hazy one. So after the final result, we will just do the data filtering and the graph will look a little bit clean. So when the volunteer will tell that he cannot perform the test anymore, we should not press the stop button, because if we can press the stop button, immediately the test will stop. But we want to record the recovery session as well for 3 to 4 minutes. So we have to just click on the recovery at that time. So almost 1 minute 40 seconds remaining from the next step. And his current heart rate is 178 beats per minute. And in the heart rate graph, if you can see that as we have increased the load in the time to time, the heart rate grows like a graded fashion as well, like a staircase like fashion. And we can zoom in and zoom it out as well with the help of the software. Every graph we can zoom in and zoom out and put a marker as well. So you are feeling okay now? Okay, thank you.
If you're feeling tired or can't run, raise your hand, we'll stop the treadmill. Relax, keep running. Good, good, very good. And continuously you need to, when the pace or load is more, you need to encourage the athlete. So it's the responsibility who is assisting or conducting the test to keep encouraging the athletes, because monotonous run is always difficult. Just seeing a wall and keep on running, and after certain time load is increasing, you're putting some stress, added stress every time. So you need to keep encouraging the athlete. So what we observed, once we encourage, so the subject was able to push little more, can go beyond. So our goal is to assess VO2max. So if we can push, or otherwise we will not get the actual or accurate data of VO2max.
So we are in the next step now. Here the inclination is 18% and the speed is 8 km per hour.
You can go to the 9 panel plot once. Select 9 panel plot. Already select. Yes, it's taking some time. And VO2. See, where the first top one, the heart rate, it's gradually increased and entered into the yellow zone. That is the maximal heart rate zone. It's already detected. that means the athlete is reaching towards exhaustion. You can see the RQ also 1.1, heart rate 193, seeing his age 32. That means 220 minus 32, 188. The athlete is already above the, so we can push. So it's a call from the instructor that how much he or she wants to push the athlete, seeing the phenotype as well. If the stride lengths are too haphazard, then also all the parameters are within the range only, but the stride is still haphazard. He or she cannot make it fulfill the demand of the running or walking or cycling, whatever. Then the test needs to be stopped. I think the subject is telling, raising his hand. So we need to stop the
So
test.
no recover. No.
Stop the test. Another, yes. Okay. So we'll stop the test. Oh, recovery, sorry. We can start the recovery part as well. So recovery phase already started. So we'll see how much it's coming down within 3 minutes. 3 minutes. After 3 to 4 minutes, we'll see.
So in some exercise protocol, there are instructions that you can just record the active recovery also. But here we are just recording his passive recovery responses as he is now stagnant. You can see his heart rate is gradually declining now. And other parameters like VO2, VCO2 is also declining. And RQ value, if you can notice, it is increasing now. It is much greater than 1. It is almost 1.3 now. So we'll discuss it in the later part, that why the RQ is increasing in the recovery session. So you have to record the recovery session for 3 to 4 minutes. And it is seen that in 3 to 4 minutes for a healthy fit person, the heart rate comes under 120. So already his heart rate is under 140. So just relax now. Feel calm and comfortable, like you have done nothing.
So you can see oxygen consumption almost came almost like a resting state, although it's not fully rested condition. So approximately 400 to 500 ml we consume during a rest, or less than that only, approximately 3. So here it's still approximately 700. So it's coming down. Heart rate also came 130 approximately, although it's a breath by breath value we are getting. Relax, Subhadip, relax. If the athlete sees his data, definitely the heart rate will not come down. So now you can stop the recovery part.
And immediately after stopping, we have to just release the athlete because he has done a strenuous exercise. So I have to just remove the turbine and reattach the mask.
If you see the recovery, oxygen consumption
So
and carbon dioxide production, the red line is always above the blue line. So that means the carbon dioxide production is much greater than the oxygen consumption. Let's coming to the smoothing part, the analysis part. We need to just save the data. Now we'll analyze the data, particularly the exercise portion first. So the first part is we need to smoothen the curve. That is the first step. So first you need to go to the edit and filter. And once you go to the edit and filter, here we have again the edit and filter value. So for research purpose or for any other purpose, if you need every second's data or to analyze it, you can directly select that particular time, what happened that time, and you can get you can see what was the heart rate, what was the VO2, FiO2, FiCO2, all those things. That is fractional inhalation of oxygen, fractional exhalation of oxygen. So you can see FiO2 always fractional inhalation of oxygen approximately 20.8 to 20.9%. Why? Because the subject is taking the ambient air only. But if you see the FeO2, that is fractional exhalation of oxygen, it's not showing here. Okay, in the another curve I'll show you. That will be most probably when the load is less, it was 18 to 18%. When the grade is more, maybe 17%, 18%, the fractional exhalation of oxygen will be. Okay, so that means the inhalation is approximately 20.9% and the exhalation is gradually going down. That means the remaining is utilized by the muscles and the whole body. So we need to just go to the data filtering part. And here you will see smoothing and rolling time average. So if we go for a rolling time average, means every 30 seconds data it will accumulate and it will smoothen the whole curve. You can see approximately here now in this zone around 11 minutes, the oxygen consumption, the blue line, initially if you see the O2 CO2 curve, the volume of oxygen consumption till 10 minutes or 11 minutes it was more, and the CO2 production was less. And when gradually the intensity increased, the carbon dioxide production, both the side the scale is same. You can see 3000, 3000. So it's not a different scale. So after a certain time, the carbon dioxide production is more and the O2 consumption is less. That means the body is moving towards anaerobic site, maybe somewhere this region. So anaerobic threshold heart rate somewhere will be there. So we don't know that exact point and that is the anaerobic threshold point or not. But from here we can detect what is the anaerobic threshold heart rate. Okay. So we need to accept the data, but later we can restore the whole data also. If we want any point of time, we need the whole data. So we can restore the raw data. You can see the option top, it was there. Now if we go to the VO2max, what is the oxygen consumption, VO2? So if we select the auto detect portion, so that is the maximum volume of oxygen consumption, and it came 40.2 for him, for this volunteer Subhashish. Okay, so we can save or we can go to the threshold value as well. So here again we have an auto detect option to go for a threshold value. So here somewhere here this point, that you can see there is a huge deflection or diffraction start happening here, this region. So manually you can detect, or sometimes auto detect try to detect, but you can manually detect the AT as well. Okay, so there are several options like this. You can analyze the data, whatever the data you want you can gather, and you can save the data. If it's a clinical population or mainly required for the clinical, you need a printed report, that is also possible. So you can take a printout of the whole report where the oxygen consumption, here it's showing poor. It's purely because of the scale, which is already the software, in the software they have fitted out this range. And they did, when we are choosing the Indian, so basically the population, when we spoke to our cosmet people, they came for demonstration and installation. So it's purely done on some South Indian population, and they took one research from the North Indian population. So approximately 100-200 data they gathered, and based on that, if I may be wrong, maybe around that, the numbers are not exactly correct, but based on data only, they created these norms. So based on that, it's showing it's poor, below poor, or so if we select other population like Caucasian or some Australian or anything, so there the number of subject assessed is more. So basically the data reliability or this range we can rely, but here based on which kind of game he or she is practicing, what is the age, what is the gender. So based on that we can change or interpret according to our own also. Okay, so this is all about, I feel, aerobic part, and we can see you can show the resting recovery part as well. Just going off, sorry. The 13th, 1256.
So what is the purpose for that?
Yes, exactly.
This is the context of oxygen. When the person was exercising, the oxygen supply was not meeting the demand at that time. So it is like you are taking a loan from a bank and you are recovering this. So this is called as oxygen debt or exercise post oxygen.
EPOC, the post exercise post exercise oxygen consumption, EPOC.
So you can just take a printout and like taking the area of this graph, you can just calculate the effect as well. And market also declined in the gradient fashion. And and as a sports scientist, we have to just give this knowledge or give this information to the coach that at this subject you have to just up to this subject the one marathon runner or one endurance type runner can go, so that his body can rely on the aerobic metabolism up to this subject, and he should try to maintain a pace where up to this subject he can just, and gradually by training the coach will accordingly design or be given in the training to increase that heart rate where the anaerobic threshold was seen, so that the performance can be increased and the speed of the marathon can be increased as well. So
basically the performance. Just interrupting, yes. So for example, mine and Devobrodo's VO2 is 70 ml per kg per minute, the all VO2 max, and my 80 heart rate is 170 beats per minute, and for him it's 160 beats per minute. Obviously, who will be better? Although both of our timings are same, VO2 is consumption, oxygen consumption same, only the 80 heart rate, for me it's on the higher side, 170 maybe compared to him, and for his 80 heart rate is 160, then lesser. Anaerobic threshold heart rate is less. And assuming both of us reach the maximal heart rate only, then what kind of interpretation you can do from here? Who is better and who has the potential through training, who can improve the performance? Lower 80 heart rate one. So obviously what the marathon runners try, they knowing this kind of heart rate most of the time, sometimes taking the sports science support, they do not want to cross this 80 heart rate most of the time. Means if they somehow increase the pace, saying okay, someone is running, so I can make up that part. So if they alter their pace, so ultimately body will just shift towards anaerobic side, and they cannot perform. Although we are thinking that okay, this much we can cover, so they try to maintain their pace constantly. So this kind of, so that is the importance of one example, the importance of knowing the anaerobic threshold heart rate, and to design the target heart rate zone as well. So to give it to the coach, what percentage of AT the athlete should train to improve endurance or to anaerobic capacity. So for that purpose also, this data required. Okay, so now we'll move to the, I think, any question, any doubt from the endurance portion?
Okay, okay. So you can see in the graphs as well that RQ graph. Yeah, if you can notice here. So in the post-exercise session, the RQ increased greater than, much greater than 1 it was. Because in that time, the carbon dioxide accumulated during exercise was started to exhale, and oxygen consumption was started to decline. That is why the carbon dioxide consumption was more than the oxygen consumption. Carbon dioxide exhalation was more than the oxygen consumption, and that is why as RQ is VCO2 by VO2, so it is much greater than 1 at that recovery time. Okay. Is there any doubt? Should we conclude here this session? Yeah. Okay, thank you, everyone.
I think we can finish. Any other question from the endurance test portion? I think most of you are hungry, but we'll take another few minutes time to show you the anaerobic power. After that, we'll go for the lunch. Okay.
Okay, thank you.
What's up?
So now Debduhita will explain the anaerobic power test. So Debduhita, you can start the explaining the anaerobic power.
Yes. So good afternoon, everyone. Now I am going to demonstrate you how to do a anaerobic test based on the protocol, which is a lab-based protocol, namely Wingate anaerobic test. So my name is Debduhita. I am going to demonstrate you the all the tests and the other things, and my friend Devabrata will assist me during the session, and my senior Shubhashisa will volunteer me again during this session, the exercise session. Okay. Now Before move to the
I'm sorry, interrupting. As she mentioned that Subhashishda will volunteer. So basically, it's not suggested to do both the test on the same day and giving an adequate rest in between. But here, as we are going for a demonstration, so technically we are trying to do it on the same subject. Okay.
So now, before moving to the main part of the exercise section, I should mention you that what is meant by the term anaerobic test. Okay. So anaerobic test is mainly comprised of two types of tests. The first one is to measure the anaerobic power, and the second one is to measure the anaerobic capacity. Now the questions arise that what is anaerobic power and what is anaerobic capacity. So the anaerobic power is the maximal power one can produce or form during a short-term all-out and specific mode of activity in terms of anaerobic metabolism process, and anaerobic capacity is the resynthesis process of ATP, which forms during this kind of short-term all-out exercise with a specific mode of exercise. With this test, we are going to assess the power, the anaerobic power, in terms of several power outputs like peak power, average power, minimal power, like that. And for anaerobic capacity, we will not get it directly, but we can derive it from the average power. What we have to do is just calculate the total work done during the test. So how we will calculate that, you just can refer your handout. It will clearly written over there that how we will calculate that. And another more parameter we can derive from the test, that is the power endurance, or you can say it the anaerobic fatigue index. How you will calculate that? It is also written over your handout. So now you can think or ask me that for which games or sports or for whom this kind of anaerobic test is necessary. So if you think about some games and sports like sprints, volleyball, football, mid distance, distance, okay, in these kind of games, the players or the athletes need a sufficient amount of power, which will be short lasting, but it will accomplish a huge amount of work or the activity. So for this kind of games, the athletes or the power should have this kind of explosive amount of power and strength, and through this test we can assess that, as well as we can improve that through training. So now we have all set to go for the main test part, the protocol, the equipment and the software we are going to use for this test. So the equipment we are going to use for this test is this Monarch Peak Bike cycle ergometer. The model is Ergomedic 894E. Okay, and this ergometer has several parts. As you can see, this is the saddle, this is the pedal, this is the handlebar, this is called the release strap, this is the brake cord, this is the flywheel, and this is the most important one, the weight basket. In this weight basket, we will give the workload against which the athlete has to cycle for the total duration of the test. Now, this ergometer is interfaced with this system so that we will see that the software will record and display second-to-second data, and based upon that, at last we will get the final result. So I will move to the software part. The name of the software is Monarch Anaerobic Test software. Okay, as we are using the Monarch Peak Bike, so we are using the same software, the Monarch Anaerobic Test software. So before starting the main test, what we have to do is just create one profile of the subject. So for that, we have to move in the database portion, and in the database you can see there are also some groups we have created. If there is no group, we have to create one, according to our choice. The name we will put according to our choice, and then we have to select one group. Here I will select the RKMVERI group. It is
Just
our
I'm
university's
interrupting.
group.
I think
Yes,
it's better for the online participants if we share the screen. Just
Yes,
1
yes.
minute. You can continue. Dutta. So those who are online participants, again, you can switch the tab to see the actual Monarch Anaerobic Test software portion, which is already shared. And in another tab, you can see the demonstration video as well.
Okay, so as I have selected the RKMVERI group here, you can see that there are several subjects. So I have already created today's subjects profile. So I will just open it. Okay, for your convenience, I will just let you see that some. Okay,
so this is basically the group information. You can edit multiple groups. For example, if you want to assess the whole football team, so you can create a group and you can add the athletes. If you click double click, you will get the athlete's name. So there Shubhashish Bishwas is already there, and multiple times we have made him in other word to. We did the anaerobic power test multiple times just to streamline today's activity or process. So, okay, continue.
So for creating the profile, what we need to put some basic information, that is the first name, last name, and the gender of the subject, then height, weight, and at last the date of birth. So if we click the OK, then the profile will be created. And next part, we have to go for the run test part. So before running the test, I have to do one thing, that is I have to set up the instrument, and the athlete have to prepare for the test. So I will request Devabrata to come, and as well Shubhashish sir, please also come here. Okay, just stand here and stand here. So to set the saddle height, what we need to just see that the saddle height and this pelvic bone height should be at the same level. So I have already set the instrument. So I will just request now Shubhashish sir to get on the bike. And the next important thing after getting on the bike, after setting
so
the
basically I'm
height,
just interrupting. So basically there are multiple numbers written 1 2 3 4 5. So the purpose is, if this time in this visit we are following a keeping the satellite 3, in the next visit by any chance it become a 2 or 4, ultimately it will affect the power output, obviously, because of biomechanics will be completely different. So, and the interpretation and the comparison will not be that accurate. So it's always better to note down the seat height, and automatically this will come here as well. So what will be the number of what is the seat height? You can see the option is there, seat height 3, 4, this kind of things. You can change the seat height as well here. And what is the starting foot, right or left? Sometime maybe the power may get affected, those who are right side dominated or left side dominated. So accordingly they can choose the starting foot as well.
Okay, so after getting on the bike, the next important part is to tighten the strap, so that while he will pedal for a very first intensity, the feet should not come outside, and to avoid the injury of wrist. So next, what I have to see, that is the angle. The angle is very much important here. We stop here, and this is a flex position of the leg. Okay, this in this flex position, what we have to see, the angle between, like if this we take the plane. Okay, so the angle between, if you want you can come here. Yeah, if you want to see it.
You can come. So just that line is enough. So you can continue with it.
So this is the flex position of the leg, and we can see that heel is in touch with the pedal. This is should be maintained. Okay, this heel should be in touch for all the time during this flex position. So if we take, this is a plane, okay, and the angle between, like the plane is going like that, and the angle between ankle and this plane is called the knee ankle angle. This should be lie between 25 to 35 degree. So it will be ensured that this is a comfortable pedaling, and he will not giving excess effort to pedal. Okay, and another also marker is there, which is also very important. If the saddle height is set too high, then we can observe that there is a pelvic bone vertical oscillation movement. Okay, that should be minimized to confirm that he is having a comfortable pedaling during the activity. Now you can see it over there.
As well as they're close.
Okay.
So this is the electric cycle, as you can see, this is electrically connected, but if electricity is not available, still you can conduct this test. But in that case, someone need to pull this brake weight like this. So you need another volunteer or another expert or who is assessing the anaerobic power. So basically, as we have an electric supply right now, so the brake weight here, you can see one magnet is there. So here you can see one magnet is there. It's a basically electromagnet. So, and here one switch is there. So it will, if we press this switch, it will drop the weight. So this time the load is on wheel. Otherwise, the wheel is completely free. Can you pedal once, sources? Now the wheel is completely free. Whenever the weight is coming, so that time the load is getting applied. So with that load, the subject needs to, or the athlete needs to paddle with the maximal effort. Okay. Okay, you can adjust you can put the weights now. So what we'll do one more thing, that is after the anaerobic power test, we'll do the lactate assessment. Blood lactate will measure on 3rd minute post exercise, 3rd minute. Why 3rd minute or 3 minutes gap will give? Immediately we can do the lactate as well, right? Any reason, any idea? Because after any kind of anaerobic, or if we want to measure the peak lactate value, actually it's a 30 seconds workout. So automatically if we measure a peak and we measure the blood lactate, we'll not get the actual lactate concentration because it's generated or produced in the muscle. So it will take some time to come into the circulation. So research says the best time to get an optimal or peak lactate is post exercise 3 to 5 minutes. So that will give you basically the activity lactate. Okay. Okay, you can put the weights. Yes.
Okay. So for your better understanding. Yeah. So as he is already warmed up and already he has done the aerobic test, so I will give the workload. Okay, the workload will be, if I select the test, please see over there, if I select the test, it will show you the workload. Okay. And according to the Wingett's protocol, it will be 7.5% of the body weight of the subject. And the target is to reach the maximum RPM so that we can get the good result. Okay. So, Devabruto, please come here. Okay,
so this cycle is already connected with the system. Okay, it's not only so the subject or the volunteer should not, who is assisting, he should not press the button when the weight should drop. So according to the Wingate protocol, the weight should drop at 70 RPM. When the RPM crosses 70, immediately the weight should drop. So if somebody is conducting it manually, so someone need to see like this. Okay, what is the RPM and the camera is, so what is the RPM? Immediately the subject, he or she needs to release the weight. But as it's a computer connected, so automatically when it will cross 70 RPM, immediately the load will be on the wheels. Okay. you can put the load. So as you can see, it's a 6 point, automatically it calculated 6.2 kgs needs to be given. I'm feeling bad about Subhadip, sorry. So same day 2 exercise repeatedly.
And 3 types of weight.
So
weights
you
are
can
there,
see,
okay.
so the break weight is the basket weight is itself 1 kg. Okay, so 1 kg, 2 kg, 3 kgs, 4 kgs, 5, 6, and 100 grams, 200 grams. So 6.2 kgs load I have given. It's already not on the wheel, so you can see freely the wheel is moving. So whenever we'll release the load, that means manually or through the system, so automatically load will be on the wheels. Okay. So you can start the test.
Yeah. So now I will conduct the test. For that,
You can come,
just
all of you can come little far.
continue. Continue, yes.
Yes. So Rangun, you can go and encourage that.
Okay. So you have to paddle. Okay. Are you ready? Okay. So I will just start the test. So 3, 2, 1, and go. Fast, 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 fast.
Very fast, very fast, very fast. Go, fast, go, 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 go. Up 1, 2, and go. Go, 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 go.
Don't stand up.
Sit down,
Push,
sit
push,
down.
push, 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 push. Last 15 seconds. Push. 10 seconds. 10, 9, 5, 4,
Yeah.
3, 2, 1.
Yeah. Very
Relax,
good.
relax, relax. Keep paddling.
Okay.
So it's a very exhaustive and tiring test. So no one wants to do it once again most of the time. And this test, according to our students, it gives a the value of time. So 1 second will not pass at the end after 15-16 seconds. It look like we should stop or give up. So here you can see basically. So this is the RPM graph and the power graph. If you go to the test data and analysis,
Yes.
can you please?
Yes, sir.
So someone is starting the time. It's already started. So this is the lactate analyzer. Okay, this is a portable lactate analyzer. For this, we have this kind of lactate strips are there, like a glucometer. But the difference is the lactate strips are too costly in the other way. So lactate assessment, a portable lactate assessment on field, it takes little fun basically. So this is on basically. So you can see those who are online. So this is the equipment part. Can they see it? Okay. So this is the simple strip portion, and this is the lactate analyzer. So on 3rd minute, we'll do the blood lactate assessment. Okay, fine. You can show the data.
Yes.
Yes. You can explain the peak power and anaerobic power by that time.
Yes. So as you all can see, this is the result. This is the final result of this test. So his peak power has reaches this much, and his average power is almost 596.15. Okay, and minimum power. Okay, these all what I'm showing you. These all are the absolute one, and for relative one, what you have to do, just divide it by the body mass of the subject. And for the elite athletes, for the male elite athletes, we can see the peak power can go beyond 1000 or 1200 watt, and for female elite athletes, especially the power athletes, it can go beyond 750 watt or more than that.
So in his case, it's 845, the peak power. So sometimes what happens, the peak power and the minimum power, you can see 281. If the difference is huge, that indicates the athlete or the subject is able to generate that much power but cannot endure it. So for in some sports, particularly as she mentioned, so in football, wing position, they need to go very fast, they need to come back once again. So that means the repeated sprint is required. So those who have a peak power, good peak power, and along with that, the minimum power is, there is not much difference. So that's basically better and good for them. So the suggestion will be, in this case, the power endurance needs to be improved through proper training. So there are several training protocols, and it's almost already 3 minutes. So we'll start doing the test. So first we need to wipe the place clear with the alcohol properly. So the first drop, we'll remove it. We'll wipe out the first drop. The second drop we'll measure. So, okay, here you can see, you can just hold it. You can see it will take 15 seconds time. Okay. So I think here also, those who are online, you can see. So now it's showing 13.7. Generally, the resting blood like 13.7 millimole per liter of blood lactate. Okay. So generally, after anaerobic test, it can go 18 to 19 millimole per liter as well. So those whose muscular adaptation is good, for them the lactate level maybe sometime it will be on the lower side. But after anaerobic test, but what is the resting lactate level then? Any idea about our resting lactate? For example, if we do someone's resting lactate right now, although it's not a fully rested condition, I believe, because a lot of torture is going on, or things are happening from here to there, moving and all those things. So any idea about the resting lactate? Generally suggested there are different literatures, but it should be below 2 millimole per liter. For marathoners, you will get surprised that they run that much of distance and for a long time, but still their lactate, generally aerobic lactate is 4 maybe 5 millimole per liter. After 2 hours of running, and that run also is much greater than our regular pace as well. They're running at a 14 kilometer per hour or 16 kilometer per hour pace sometime. But still after that also, you will see this kind of, so regular training, how the adaptation happens at our neuromuscular level, that is a classic example, the blood lactate and the metabolic alterations basically. So our metabolic changes when we are stressed or get exposed to that particular stress, and when they are getting that stress, it's completely different, and the response, the physiological response is completely different for both of us. So this is all about the anaerobic power test right now. So any question, any doubt from the anaerobic power test? Anything? If no, then I think we can end this session here only, and we can go for the lunch. Thank you, those who are attending online. Thank you, all of you.
Thank you very much.
So we'll take a 40 minutes break and we'll join maybe around 2:15. Okay. So we have a post lunch. We have another one session that is basically the biomechanics and human movement session. So you all are welcome after the post lunch. Thank you, all of you.
So welcome to this session of the workshop. So in this workshop, we'll talk about the biomechanical analysis. And this is part of the pre-conference workshops series organized named as APPICON. So this workshop is being organized at the Department of Sports Science and Yoga. My name is Subhadip. I am an assistant professor at this department. And we have Professor Manohar Kumar Pahan, who is also an assistant professor in this department. So today we will talk about biomechanical analysis. So biomechanics is a subject where we study the structure and function of biological systems under the action of forces using the principles of mechanics. So here, can you go back to the next, in the next slide, please? Yeah. So here in biomechanics, those forces may have internal origin or they could be external forces. So the internal forces could be produced by the muscles, and of course external force will have an external origin. So if we talk about the subdivisions of biomechanics, so we can talk about the statics and dynamics. In statics, we study the object which is at rest or moving at constant velocity. So its velocity is not increasing or decreasing with time. In dynamics, we talk about the accelerating and decelerating bodies. So here the velocity is increasing with time or decreasing with time. So another way, as in the next slide, so in another way also we talk about the subdivisions. So those are subdivisions are kinematics and kinetics. So under kinematics, we talk about the position, velocity and acceleration of the body. And in kinetics, we talk about the cause of the motion. That means the forces of the bodies. So biomechanics is a highly interdisciplinary area of work. So many people from many subdisciplines of biology, medicine, orthopedics, biomedical engineer, physiologist, sports medicine specialist, people from the background of kinesiology, they study biomechanics and contribute to this ever-growing field of biomechanics. So, the working area of biomechanics is vast. So, but in this workshop today, we'll concentrate on the human body movement. And we know that the previous research on biomechanics helped us to understand the gait patterns and how they are disrupted in different disorders. And those understanding help us to design a better intervention processes, etc. Today we'll talk about the sports biomechanics, which is an interesting area of work. So in sports biomechanics, we talk about the body movement of the performer using the principle of mechanics, and also the interaction of the performer with the environment. So different private teams and government bodies often hire biomechanics specialists to understand the performance, to better understand the performance, and to perform the analysis of the performance, and to design a strategy for which may help us to achieve better performance of the athletes. And another aim of this kind of study is to minimize the risk of injury. So as we start the demonstration, so before we start the demonstration, we should cover some basic terms. So, so you will hear those terms when we show the video analysis, how to do the video analysis in the context of a specific sports. So let us go through this preliminary terms. So we'll talk about 3 mutually perpendicular planes: transverse, frontal, sagittal. So these planes are mutually perpendicular with each other. That means the angle between these planes are 90 degrees. So on the left side, you have transverse plane. At the middle, you can see the frontal plane. It divides the body in the front and rear parts. And you have sagittal plane, which divides the body on the left and right side. And now on the right hand side, you can probably on the left hand side of the screen, you can see 3 principal axes. So these axes are also mutually perpendicular. So we have anterior posterior axis, And we have left right axis or horizontal or frontal axis, and another axis you can see is a longitudinal axis. So these are the three axes and these are the three planes. Now we should talk about some basic movement pattern like abduction, adduction, circumduction, lateral rotation and medial rotation, etc., etc. So let us go through those terms one by one. Can we please go to the next slide? So abduction involves the movement, usually a rotation of a body part or segment away from the body. And adduction involves bringing of this segment of or body part close to the body. Circumduction, the limb is rotated in a circular pattern. If we go back to the previous slide, so you can see at the panel below, at the middle of the panel below, the example of abduction, adduction, and the circular motion, which is being called as circumduction. There are other types of motions also, like medial and lateral rotation. So rotation of the anterior surface of a limb towards the midline of the body is called medial or internal rotation. Or if the rotation is away from the midline, then it is called lateral or external rotation. If we go back to the previous slide, so we can see the example of internal rotation and modular and medial rotation at the panel given below, the figure on the extreme left on your screen. So these are internal rotation and medial rotation. So another important movement pattern is flexion and flexion. So you can see the example of flexion and flexion at the first panel above. So on the left hand side, you can see flexion and flexion. So can we go back to the next slide? So flexion of the shoulder or hip is the forward movement of the arm or leg, and extension is the opposite of flexion. And two other important movement patterns are plantar flexion and dorsiflexion. Plantar flexion is a foot movement in which the toes of the foot flex downwards, and dorsiflexion is the upward flexion of the foot. So these are the few basic terms which you encounter when we show the video analysis results. So today we have Professor Manohar Kumar Pahan with me. So he will show you the linear kinematics results in the context of a specific exercise, which is weight training related squat exercise. So he will show the various steps, how to prepare the subjects, how to acquire the data using camera, and subsequently how to analyze those data using a freely available software called Kinuvia. And he also saw how to visualize the results and etc. So Manohar is not only a assistant professor here, he is also an accomplished sports person. So it is over to you, Manohar.
Thank you, Dr. Subhadip, for a good introduction. In this workshop, we have selected one exercise, that is the squat exercise, for the demonstration of the exercise for the body movement and for the analysis of the video. Basically, after the analysis of a squat exercise, when we understand how to track the path, how to track the speed, then after we can further track the sporting movement, that is on the high movement. So before we start, let's have a look for the introduction of squat exercise. So in this image, you can see the first, second, third, fourth, and fifth. So basically in a squat exercise, the hip of an individual goes down by flexing the hip joint and flexing the knee joint. And in that condition, we call it the descending phase. So in that, there is a dorsiflexion of the ankle joint. And in third, there is a final position. So there is in final position, we have shown the half squat. It means it has just touched the 90 degree. And if the hip is around the 90 to 45 degree, we can call it as a quarter squat. Okay. So the full squat is breaking the 90 degree. So in this exercise, we have just performed the half squat exercise before the not beyond the 90 degree, but above 90 degree. So in the ascending phase, what we do is we just gradually lift the hip up and coming back to the standing position. So when we do perform this exercise from final position to the initial position, there is a the extension of hip joint and the knee joint, and on the ankle there is a dorsiflexion. So this was the lateral view of the exercise, but when we observe this kind of this exercise from the posterior or anterior view, you will find that there is an outward movement of both the knees. You can see here the outward movement both the knees. So this is done to prevent injuries, the knee injuries, and sometimes we call it the jumper's knee injury. So to avoid that, we try to just take the knees in the outward direction. So the outward direction means you have to just follow the line of your toe. As your toe is placed, you have to follow the line, and similarly when you go down, your knee should go follow the toe line. Okay, so these are some primary and secondary muscles that are used in squat exercise. The primaries are the gluteus maximus, hip flexors, and quadriceps. And the secondary muscles are abdominal muscles, lower back, hamstring, and gastrocnemius. Okay, so we are coming to the analysis of video part. But before going to the video, there are some preparation we have to do. The first one is the selection of movement. So this is the thing we have to decide. So the selection of movement. So here we have two kind of movement: the flexion extension and the knee, the movement of knee that is outward. So first select the movement, and after that select the plane, the movement in which the plane in which the movement has been done, and after that select the axis of joint to which you want to measure, then select the view, and the last one is the placement of camcorder. So while you place the camera should be placed in such a height that it can measure the movement accurately. Suppose in the squat exercise, if we intend to measure the movement of the hip joint, it means you are going down and you are coming up. So the camera should be placed in such a distance that it can measure the whole movement of your hip, as well as it can track the movement of your hips, and we can say that okay, the first one is that to track the movement, you have to just place the camera in a such distance and in a particular height. Okay. So the next one is the selection of view, the preparation of subject. So we have some in preparation of subject. The first one is the warm up. Make sure that your subject is warmed up. Now the second one is locating of the surface. So the platform in which your athlete will perform the exercise. The next one is explanation of movement. So every exercise or every movement needs some explanation, and can be conducted in different way. So we need to explain the movement. The next one is the preliminary trials. For this, your athlete, you should give a chance to athletes so that they can do a particular trial and they can understand the movement. Now the next one is the measurement of height of subject. So in this workshop, we have performed the squat exercise. So after lifting the weight, when you will place the weight bar, the barbell on your shoulder, and the weight will be placed on it. So definitely you will come down, and as you spread your legs, your height will slightly decrease. Okay. So you have to just measure the height. What is the height of the subject at that position? And now you have to measure the barbell, the length of barbell. So this is the preparation part. Now next one is the placement of marker. So here are some dots. You can see where you can place the markers. So the anterior and posterior side, and depending upon the movement, you can place the marker as you intend to measure the movement. So when you see it from the lateral side, you can place the marker on the axis of the joint from where the movement will take place. And the marker can be anything of contrast color. Either it may be a dual tape, or either it may be a chalk, or either it may be a cotton. anything that can give a contrast color to the background or the body. Now, gathering and analysis of data. The first one is recording the movement. So in recording the movements, first of all, check the position. First, check out the position and make sure that the subject stands at the particular platform, as well as camera is placed at the correct height and correct distance. And make sure that your athlete is ready to perform the exercise. And now start the recording part. After the recording part, you can transfer data from camera via data cable, memory card, or wireless transfer. And after that, just save it in a particular or relevant file format. Now next comes the analysis of video. So this part we'll be doing by the software using Kinovia. So Kinovia is basically a free software. So anyone can download it and they can practice. Okay, so this is the Kinovia software. So when the software is installed and you have uploaded the document here, the video file here, now you can import the video. So here at the left side, you can find the import toolbar. From there, you can import the videos. So we have here, I have selected already the video. So from the beginning. So basically this is the video. So here there are several tools. Selection of the video, to which length you can you want to assess the movement, and here is the speed, at which speed you want to observe the video. So first of all, just play the video and see, visually observe the movement. You can see as the hip is going down, there is a hip flexion, knee flexion, and there is a dorsiflexion of ankle joint. And when the subject is coming up, there is a plantar flexion and extension of the knee and hip joint. And you can also observe the movement of bar, how the bar is moving up and down. So let's do some movement analysis here. So here are several tools. So first of all, let me show you how to track the movement. So here in this case, if you will press the control key and scroll the mouse, button on the mouse, you can zoom it. So after coming here, just place the right key. You have a hand sign on your cursor, in a cursor. So just come to the marker we have placed at the hip. Just right click, track path, right click, configure. Then again in this section, just type the name. What is it? Hip joint marker tracker. So write the name only and just press apply. After this, you can leave this in the same zooming position, or you can come back. Now just play. Okay. So as the subject will go down, you will see that how the tracker is tracking the object, the movement of the hip. So we have three markers basically in this 4 markers. The first marker is placed on the barbell, the second one is on the hip, the third one is on knee, and the fourth one is on the ankle joint. So right now we have seen the movement of hip joint. Now if you want to check the movement of the barbell, just do the same procedure. Right click, track path, again right click, configure, edit the name, bar track. Okay, you can change the color or the font size or the tracking object size. Just place OK. And now see it. So while the video will play, it will take time. For the first time, it will take little time to analyze the movement. Okay. So we are just doing the right click and ending the tracker. So now when we'll play it, from the beginning, we will see how the software has tracked our movement. So this is the path which our hip followed and the barbell. Okay, so this one was the first part. Now, what movement is being performed? We want to see that what are the parameters it can measure. So here are the, when you do the right click, you will see there are different parameters such as the position, distance, horizontal displacement, speed, acceleration. So there are various things. So according to your need, select the parameter and you will just get the data. So while you will see the speed, you will find that a data with a reading with a px.s. It means pixels per second. So we need to convert it in a meter form. So as I said in the earlier, that you have to measure the height of your athlete. So the first one is, first just measure the height of the athlete. So we know that after holding the bar, the height went 168 centimeter as we measured earlier. 168 centimeters, and define it that it measures the vertical axis. Okay, now when you do this, the reading automatically will change in this side. So now you do not need this vertical bar, so you can shift it anyway. Now when you play this, you will find the speed, at what speed the movement is being performed. Similarly, meters per second. Okay, so now it will measure in meters per second. The unit will change to pixel per second to meters per second. Now let's see the position. To check the position, hip will show the speed and the bar will show the position. So the data you are getting from it. So this is one part. So we have tracked the movement. Now the next one is, if you want to track the angle, so it can also be done. So we'll start tracking the angle from this part. So from this toolbar, just select the angle tool, press anywhere, but in this workshop we are placing the we will be measuring the angle of knee. Place the marker at relevant place. Okay, after placing the angle, right click, configure, change the name, angle knee. Font size, you can check the font size. Now you have to do one thing, that is start tracking. If you will not click this button, start tracking, the movement will not be tracked. Let's see if we do not track the movement. So this is the thing, it will disappear. So when you want to track the movement, you have to select the tracking path or that start tracking. Now you will see that it will track the whole movement as the subject will go down and as the subject will come up. So we are just measuring the angle of only one repetition of the knee joint. Now this was the video analysis or the visual analysis. So for our research purpose, if you want to get the numerical data, the quantitative data, we can gather this data by clicking the tool button. So here are several options to which you can get the data, numerical data. So linear kinematics, let's take the linear kinematics that we have measured the tracking path of the hip and the barbell. So we can get it from the linear kinematics. So these are the data. So this is the graph. Graph, okay. So here we can select the hip only. Okay. So here we are selecting the hip movement and yeah, the speed. Okay, so now according to your need, you can change the parameter. This is the only speed, the speed of the hip joint. So if you want the position or the total distance, just click the total distance. It will give the reading of total distance. So it is in the cumulative form. So as you know that at what time you have completed one repetition, you can just break the data and you can get the data of per repetition, ascending and descending phase. Accordingly, you can change it to anything you want to get. So you can get this data in your Excel sheet also. So here are two options, export graph and export data. So when you click this export data file, it will come in the Excel file. So this was the linear kinematics and of that the data of movement tracker. So if anyone is interested to get data of angle tracking, just come to the tools, angular kinematics. Here is the data. So here are several options what you want to take as X or Y axis. Just select it and you will get the data in your Excel format. Okay, so this was the demonstration of Kinovia software, the movement analysis doing the Kinovia software. So basically this software is free and you can practice the same using different kind of body movements by your own or by anybody you can find in your home or in the local gyms or any movement or any human movement. Okay. So when you have gathered the data, the last part is to conclude the movement. So when you conclude the movement, you have two things. The first one is the numerical data and another one is the exercise that you have visually observed. So when you conclude, do not go to the only the data section, the quantitative data, but also keep in consideration the visual movement. Right now, you can see this. We have recorded that movement in posterior view. So you can see here the angle of the bar position from the left side. The height is a little bit more, and at the right side, the bar is lifted. So there may be anything. The cause may be anything. It means the subject may have any injury, or is there any lack of strength on either side of the body, or this weight, the weight he is holding is very light for him, and the weight is only 40 kg. So if he is having the capacity of lifting the weight of 120, 140, so this is very lightweight for him. So he will not give his full effort, or he will not show his full technique in this kind of movement. So there may be any reason. So while concluding the movement, just look the preclinical conditions of the athlete, and also after the completion of movement, just take the feedback that how you felt and what was the resistance. So this was the thing that we can measure for practice purpose. You can measure anywhere. So this was the basic exercise. Now when you will see the sports exercise, see how the sports exercise are being performed. So the sports exercise are basically, they are dynamic in nature. The movement are performed is in multiple planes, not only one plane, but they can be performed in the multiple planes. So to moving to this part, to the analysis of sporting movement, first we need to understand, or first we need to practice the movement that we can perform or we can analyze in a 2D by using the 2D cameras or the 2D platform. Once we have practiced it, now we will understand the movement, that which kind of movement we want to capture in the sport field. So here are several things: the running, jumping, throwing, and there are 2 throws. So if we place a marker like the sagittal area, the sideward area, the lateral area, suppose in this shoulder, hip. So when the body will turn, when the releasing part of the javelin, when the body will turn, definitely the camera will not track the movement of the soldier. So that time we will have problem. So in that condition, we have a advanced technique of 2D analysis, that is a 3D analysis, and 3D analysis can be done by the magnetic marker. So when you will put it on the body, it will just stick and it will give a whole 3D diagram of the surface and the body movement. Okay, so this was all for the workshop, analysis of biomechanical movement. Thank you. Have a nice day.
So the next session will start within 10 minutes.
Hello, everyone. Good afternoon to all of you. So those who are attending online, so the next session, fun quiz. So we are almost at the end. We have gone through the biomechanics laboratory experiment demonstration and hands-on training on acquisition and analysis of exercise-related body movement. Most probably during a squat, we have shown that video and how the angles change. You have already gone through it. So now we are almost on time, but slightly running a little late. All of you. So those who are attending online. So the next session. So now we'll start the fun quiz. So this is for mainly for the offline candidates, but those who are interested attending online also, you can attend this quiz. So for this, basically you need a Kahoot, which to install Kahoot app. We are not conducting this quiz in a Google form. So I'll request all of you just go to the Play Store, Google Play Store, and you will find Kahoot app, Kahoot. So requesting everyone to install the Kahoot app. We are facing a technical glitch. Just allow us to fix it just for 2 minutes.
Okay, good afternoon, all of you. Once again, so now we are going to start the quiz. So basically, in this quiz, we have 10 questions. So whatever happened in today's workshop, from there only some questions are there, maybe one or two some general sports related questions. So we'll start the quiz. So in each question, 4 options will be there. So end of that, who will win the quiz? Most probably there is something. Okay. Okay, so one question was related to on biomechanics basically. So in that question, the video was somebody is lifting weight, the same GIF video, what was in the introductory slide. So the same posture it was done. Anybody knows what was the, Okay, so that is the common question and answer. So one question answer already revealed, because as we have not done, so that's why I revealed that answer and question. So there are 9 different questions as well. Okay, so I am starting the quiz. So the question will appear here only. You have to see, and 4 colors will blink. Basically, as you can saw that screenshot or during installation. So maybe green, yellow, red. So here, whatever the option you are thinking that it's correct, that option, that same color you have to click in your phone. For example, if 4 people are giving the correct answer, in that also, who is responding first, based on that, the system will automatically rank the participants. Okay, so competitiveness is much greater, huh? Yes, maybe. That conflict we can avoid here. Okay, so I am starting the quiz. Can we start? So it will take hardly 5 to 10 minutes, I believe. Okay, it's on sports and exercise science, today's workshop. 3, 2, 1, go. So how many medals India won in Tokyo Olympics 2020? Options are 5, 1, 7, 19. Nobody will say anything, whatever you are thinking. So if somebody's network connection is poor, we can't do anything. Sorry in this regard. So it's over. So 3, 3, 6 plus 4, 10 participants already answered, and only 3 choose 7. 4 participants choose 1. We have not asked about the gold medal. The question was the how many medals India won in Tokyo Olympics 2020. So the correct answer is actually including gold, silver and bronze. It's 7. Okay. And 19 in Paralympics, basically, as I can recall. So yes, 19, right? Yes. So let's see. Good. Who is Bhagya? Okay. Obi? Who is Obi? Obi, okay, Babu. Okay, it's just the first question. You got the, I think, some idea how it's going to happen. Okay, the next question. So you have to be very fast. Okay. Okay, the next question. So it's a refreshing session, I believe. Is there any audio or not? I don't know. Okay. At what RPM speed the load basket should drop in Wingate power test? One 10, 80, 70, 100. Have to be very fast. 7, 6, 5, 4. Okay, got the response. So 7 of you have chose 70 RPM, and it's absolutely correct. Those who chose. Okay, next we'll see. What is the name, Kunal sir? In which name we are attending? Anonymous. Okay. Again. Okay, good. Competition is going on. Next, see. Next question. For which calibration, the CPAD machine, we have to use syringe? Air calibration, flow meter calibration, metabolic calibration, and mixing chamber calibration. Eleven already answered. It was flow meter calibration. So syringe, that means a 3-liter volume syringe. So it was a volume calibration. Okay. Score now. Who is Obi? Okay, to be very honest, he don't know the questions. Okay, but he's a part of the department and knows all the equipments and procedures. Maybe that is impacting. And Obi has the highest answer streak of 5. Babu is coming. Okay, tough competition with Babu. Who is Babu? So the norms we should have a little changed. The exact name you have to put it here. Otherwise, okay. So can I go to the next question? If a person runs on a treadmill for 45 minutes at medium pace, what type of exercise he or she is performing? Endurance, strength, balance, explosive strength. Easy question, very easy question. 6 answers, 7. Only 6 seconds left. 8. 8 answers only. 9, 10, 1, 11 answers. Okay. Most of you selected the correct answer only. It's the endurance type because it's 45 minutes exercise. So those who have poor network, they can directly complain to the network. So nothing in our hands. Sorry for that. So let's see the scoreboard. Okay. Obi Babu Bhagya is in the same point. Okay. Next. 6th question, most probably, or 5th? 5th. Okay. 5 out of 10. Which exercise was demonstrated in biomechanics workshop today? Everybody knows. Yes, 11. Now this time everyone's network worked properly and all those things, right? When the answer is known. Okay, good. Okay. See. Okay, good. Tough competition between first 2, 3 also. 6th question. Which type of, not a ergometer here, is not a type of ergometer, not a type of ergometer. 8 I already answered. I believe all questions are easy only. Okay, everybody selected correct only. The body composition analyzer, 2 easy question. Okay, let's see the scoreboard. Okay, so Obi is going first, then Babu. Who is Babu? Who is Babu? So there are 3 professors we are having, and they are not disclosing their identity. So at the end also, if Babu somehow comes first, so we also don't know, and no gifts in that way. No prizes, huh? Yes, because we don't know who is Babu. Bhagya, Joita, RG, who is RG? Okay. You have to be very first. If you put it very first, then the entire score will change. If it's correct also. The next question, identify the Olympic water sports. Olympic water sports. Skiing, kayaking, triathlon, judo. Okay, it's a kayaking. So there are different water sports, basically Olympic water sports with boat basically. One is rowing, kayaking, canoeing, then sailing, and in the last Olympics, most probably surfing was also incorporated. So surfing as well. Rafting is still played as a adventure sports, but not as a Olympic sports. So these are all with boat on water sports. and some sports are in water as well, and some are underwater, like deep sea diving. So in water sports also there are different categories. Okay, so okay, let's see the scoreboard. Okay, good. So going to the next question. 8 of 10. Maximum how many electrodes can be attached in the EEG machine you have seen today? 12, 17, 14, 20. They don't know? Okay, so that's why the equal distribution we have seen. Okay, so that equipment was a 17 electrode EEG equipment. Okay. Nine of same. We can measure flexibility by which type of these equipment? Sit and reach box, backstrain dynamometer, flexodynamometer, bicycle ergometer. Flexibility. Any idea? Wild guess? 7. Yes, it's absolutely correct. The sit and reach box. The box you are seeing there, it's a sit and reach box where you need to sit, that whiteboard, and you have to just push that wooden piece over there. So that will basically give you the idea about sit and reach flexibility. And the last question. Okay. You will not answer the last question. What is the measuring unit of relative VO2max? ml per kg per minute, ml per minute, liter per minute, kg per minute. I think once again an easy question. Then disqualify. Okay, ml per kg per minute. 9 of you selected ml per kg per minute. So let's see the podium. Audio is not attached. 7 out of 10. Bhagya, very good. It's a very good response. Who is Babu and Bhagya? Babu. Bhagya. Babu? So we'll not consider first one and second position as third position. Oh, third is already disqualified because we don't know who is Bhagya. Oh, sorry, third Bhagya. Who is Babu? I don't know. Okay, hope the goal was just to orient you before leaving the workshop, or we are almost at the end, just to simulate you or recreate or recall the whole thing what we have gone through today. So hope you have enjoyed. Do you have enjoyed the quiz portion? Okay. So this is all about today. After that, we will go for the certificate distribution, and we'll take a group photo. And after that, it will be over. Okay. So dear participants, we are almost at the end. We have finished the quiz, and soon we'll send the feedback form to all of you. It will be a Google form. So I'll request all of you to submit the feedback form maybe by today evening or by today only. And after this, we'll start the concluding remarks or valedictory portion of this workshop, and we'll distribute the certificates as well. Okay. Thank you, all of you. Those who are attending online, please be in line. Maybe after 5 minutes, we will start the certificate distribution portion. And concluding remarks from our Maharaj, Mrinmoy Maharaj will deliver the concluding remarks. Thank you all. So hello participants, welcome back once again. So we are almost at the end. So basically we'll go for the certificate distribution to the offline participants after some time. By the time those who have attended this workshop online, hope you got benefited from this workshop. And if you have any questions or any doubt, you can drop a message or mail to our department mail ID or my personal mail ID. I'll share it in the chat box. And thank you for participating in this workshop. And all the best. And thank you once again to the organizing secretary of APPI, APPICON, and general secretary of APPI, and all the committee members who selected us for the organizing this workshop. And I'm thankful to the university, thanking university to provide this beautiful facility, and all the participants who have attended online and offline, and my dear students and scholars and other faculty members of this department. Thank you all of you for attending this. So see you soon, maybe sometime in the through offline, those who are attending online or in some other platform. Thank you all of you.